Still he is not connected.
अभी हो
Hello,
जाएंगे.
Shailen sir.
Yes, yes.
Okay, okay,
He will be connected soon.
okay, okay.
हेलो प्रज्ञा मैम. हेलो प्रज्ञा मैम. हेलो.
Yes.
हेलो डॉक्टर.
Yes, I can hear you.
Yes. Okay, ma'am. So now I'm sharing my presentation.
Yes, sir.
Is it visible?
Yes, sir, it's visible. Okay. So now we are going to start. Sir, stop sharing your screen.
Okay, ma'am.
Stop sharing. Your screen is still visible. Click on that and stop presenting. Yes, sir.
I have stopped.
Yes, sir. Now we are starting our conference, international conference. Very good morning to all of you. Today is the second day of international conference of the chemical sciences, recent innovations of the chemical sciences. Today also we have many eminent speakers which are with us with their different knowledge in different fields of chemistry, including in this chemistry chemical sciences project, or we can say webinar. We are discussing all about different trends and technology which are recently been innovated with our speakers. So today we have list of speakers like Professor Brahmadev, Professor Santi Mukkal, Santra, Dr. SP Singh, Dr. Archana Pandey, and many more. So be stay tuned with us with different speakers. So I wish all the speakers, I welcome all behalf of AK City and Chemistry. Professor Brahmadev is a principal of Government PG College, Chunar, Mirzapur, UP. Over to you, Brahma sir. Hello. Hello. Yes. Hello.
Am I audible?
Yes,
Am I
sir, you're audible. Yes, sir. Well,
Thank you. I start addressing you. First of all, I thank you all. It is an immense pleasure for me to honor you all. Honorable VC AKS University, Satna, MP, Dr. Professor Santi Mukkal, Centra, Pittsburgh University, USA, Dr. SP Singh, Senior Scientist, IICT, Hyderabad, India, Dr. Archana Pandey, keynote speaker, Professor and Head, Dr. Harish Singh Gaur, Central University, Department of Chemistry, India, Dr. D.K. Sharma ji, Senior Head Department of Chemistry, APS University, Riva, Dr. Puneet Pathak, Research Scientist, uh, Haryana, Professor Neelam Kicharia, Government PG College, Principal Government PG College, India, Dr. Anirudh Prasad Chaudhary, Department of Chemistry, UP College, Varanasi, Professor M. A. Qureshi, Chair, Professor King Fahd University of Petroleum and Material, Saudi Arabia, Professor Ambrish Singh, Dr. A.P. Mishri, Professor at Dr. Harish Singh Gaur University, Dr. Amit Kumar, Dr. A.K. Vasudevan, Dr. Chitrashen Gupta ji, Dr. Professor M.S. Singh, Dr. Raj R.N. Tripathi ji, Dr. Subedar Yadav ji, Deputy Organizer, Government PG College Chunar, Dr. Shailendra Yadav, Organizing Secretary of this university. It gives us an immense pleasure to welcome such distinguished personalities from different parts of the world. In brief, I would like to tell you that ours is a very small college located in very extremely rural area of Mirzapur district, UP, and I am very much thankful to all such dignitaries who have given their invaluable time for organizing this webinar, rather say international webinar. I am thankful to Dr. Subedar Yadav and Dr. Shailendra Yadav and all such great scholars who are contributing to the organization of this webinar. I don't know much about science so far as I know that chemistry is the central science, and without chemistry we can't think about science. And chemistry is a scientific study of substance when it is mixed with other matters. It reacts differently, placed in different conditions. Just over 100 years before, the life of human beings on this earth was very miserable. There were no facilities, and the life span of human being was very short. But during the last 100 years, researchers, scientists, and inventors have invented many things. Many technologies have come to forefront, and these technologies, discoveries, and researches have made our life worth living on this earth. I am reminded of a very famous literary person's statement, Dr. Murk Raj Anand, who once said that among all the planets of this universe, perhaps this Earth is the most disturbed planet. And during this change scenario, in Corona period, these researchers, scientists, and chemical scientists have to find the solutions to the many problems which are challenging the very existence of human beings. But these inventions and innovations have posed problems also. and they have affected climate and environment adversely. It is now up to these scientists and researchers to mitigate the contamination of air, water, pollution. There are two major scientists discoveries. So many persons are talking about 10 new innovations, and they are claiming that these innovations will drastically change the world. So I am very much thankful to all such persons who are contributing to the organization of this international webinar. I express my thankfulness to Dr. Shailendra Yadav and Dr. A.P. Misri, who have collaborated us, and in their collaboration, our college is organizing this international webinar. This conference on the topic will bring out some fruitful results, and such webinars must be organized and promoted in this corona period. I think that without this virtual meeting, it was not possible for us to commute or interact with such dignitaries who are living in various parts of the world. So I am hopeful that some new things will come to us through this international webinar, and my good wishes are for all the speakers, keynote speakers, organizers, and participants. I express my good wishes for the success of this international webinar. And lastly, once again, I offer warm welcome to all participants and dignitaries who have given their invaluable time to the organization of this international webinar. Thank you, madam. Please go ahead. Hello. Hello,
Thank you, sir.
madam.
Hello. Yes, sir. Thank you, sir. It was nice to hear you. And we are highly privileged to listen to you. So, on our next link is Dr. Santra, who is our first speaker. He has completed his PhD from IIT Bombay under Professor Anil Kumar, and its topic was organic synthesis and synthetic polymer chemistry laboratory in the Department of Chemistry. His doctoral research was focused on the multi-step synthesis of amino acid-based biologically important small molecules and biodegradable dendritic, hyperbranch and dendrimer polymers for drug delivery. After defending his PhD thesis in 2006, Dr. Santra immediately joined Dr. J.M. Perez's lab at the Nanoscience Technology Center, University of Central Florida, as a postdoctoral research associate. He was promoted to the rank of research assistant professor in 2010. Formulation of various metallic and polymeric nanomedicines for cancer treatment and nanosensors for the timely detection of the infectious disease were the important goal of his research. He has also mentored a group of MS and PhD students working in the lab. Dr. Santra, over to you. I welcome you on behalf of RICS University Chemistry Department. Over to you, Dr. Santra.
Thank you very much. Please confirm, do you see the screen?
Yes, sir, you are visible.
And my screen?
Yes, sir.
My screen is visible?
Now it's not visible. It's visible. Just maximize your screen. Maximize the PPT. Yes.
Okay. It's good now?
Yes, sir.
Okay. Thank you very much. I would like to thanks to AKS University in Satna and Government PG College in Chuna to reach out to me. In particularly, I would like to thank my friend Dr. Soilendra Yadav. He put a lot of efforts to contact me and then calling me and knocking every time. Sir, there's 6 hours from now, 3 hours from now. Thank you very much for keeping me in track because it is now over 12:30 in the midnight. So thank you very much for your effort. Also to Dr. Chitra Gupta, who was my friend and now he's also my friend, and we studied together in BA2 while I was doing my master's. So thank you both, and thank you AKS University and Government PG College for this opportunity. So today I would like to give a little overview of what we do in our lab in Pittsburgh State University. And the title is Polymer-Based Nanomedicines for the Targeted Drug Delivery and Treatment of Cancer. Before I go to the talk, I would like to take this opportunity to introduce my university over here who is hosting and helping me grow in the research. This is our few pictures I collected for you guys, but importantly, I'd like to focus this page to the students who are following this webinar that we have in our chemistry department, a polymer chemistry program, where we introduce batch undergraduate and master's degree. In particular, if you look at the rest of the country, the polymer chemistry degree is very rare, especially when it's undergraduate degree. So here, the Kansas State, they put a lot of money to increase the education in polymer chemistry. So the students should be looking at this for the BS or MS degree in the polymer chemistry. And also, you will see in my lab a lot of students from abroad coming here. And this is a very good platform for the students who wants to pursue PhD in United States. Because before you go to the PhD, any school, you need to have a, basically you need to have another degree so that you are eligible for the teaching assistancy or any kind of assistancy in the PhD program. So students from India particularly, they try to have another, say, MS degree. If you have MS degree in chemistry, so you can have MS degree in polymer chemistry in the United States, and this degree would qualify you for assistancy for the rest 5 years of your PhD program. So this is very, very important for students who are planning to do PhD in United States. So you can see that we have we are the gorillas, home to gorillas, and we are very good in football here. And then we have, this is the one part of the chemistry department where I have my labs, and another part of the chemistry department is here. This is the research center. So we do a lot of research in the university. So before I start, I'd like to thanks to my postal stamps, my students who contributed. I'm presenting on behalf of them. I do nothing in the lab. I just try to organize and try to give them opportunities so that they can work. So I'd like to thank all my previous students graduated from my lab. And some of them also moved forward as a doctor because I do a lot of biomedical, most of the work is biomedical research. So you can see there, there are MD, PhD and everywhere, and a lot of names will be coming and pictures will be adding. So a lot of opportunities are there in this lab because we do a lot of biomedical research, and I encourage particularly students to move on, either graduate students or medical students. Research, let's go to research. What do we do in this lab? Overview, a little bit of overview of what we do here. Like in my PhD, I trained myself on the synthesis, organic synthesis, and synthetic polymer chemistry, so stepwise synthesis of polymers, and also small molecules like biologically active molecules. So you can see that activatable products and MR probes. MR is the magnetic resonance probe. This is kind of MRI, we say. So we use these we synthesize these activatable products and MR probes for diagnostics and treatment of cancer, small molecule based. Also, we synthesize here a lot of small molecules eligible to give you dendritic polymers. So what is dendritic polymers? They are like, when you talk about polymers, it's like polymer linear, say from here to Satna in UP, something like that. But it's not. Dendritic, when it's like a soccer ball, it's like a three-dimensional architecture. So we'll be taking a lot of examples of how you can create a dendritic polymers and how we can use those dendritic polymers for the drug delivery for the treatment of cancer. So that is one like polymer synthesis, and we use those polymers to the drug delivery system by formulating them as nanomedicine. And we target for the cancer treatments. There's another very important work that we do in this lab is the nanosensors for the detection of infectious disease. We have published several papers on the detection of Zika, Ebola, E. coli, influenza, and all. Now we're working on, of course, COVID-19 and see what we get. However, thinking of chemistry department and talking to the student from the chemistry, I would like to focus more on the synthesis of dendritic polymers, and I'll take a little bit to the nanomedicine and show their potential, how beautifully we can use them as a nanotheranostics. These are a few publications selected. This the left-hand side is like selected what I published from here. And this is selected also what I published before I joined as an assistant professor. So we keep on building. I try to balance between publication and the grant. We are fortunate to get grant from National Institute of Health, NIH, from USDA, United States, Department of Agriculture, American Chemical Society, Petroleum Research Fund, and so on. So try to balance. So I try to keep like 4, 5, 6 maximum publications per year. So it's nice to balance between the proposals and the manuscript. So I'll just move on. And here's the nanomedicine. So we know about medicine, a little bit of thinking of student in front of me. We know medicine when someone is having cancer, say I have cancer, for example. So I go to doctor nowadays, still nowadays, we go to doctor, a doctor says, oh, you have first stage, second stage, third stage cancer. So they start with the chemotherapy, say, for example. So they will have you have IV, and then they will inject drug in the bottle, and then you go to the blood circulation. Good. Sometimes we are lucky, we get cured. But what happened during that time? We have seen when a patient going through this, chemotherapy for this treatment of cancer, you can see immediately the loss of appetite, cannot eat much, then hair fall, and then at the end, slowly, the heart is not working, the lung is not working, and so on. So most of the time, a majority of them, you'll see the patient is dying, not for cancer only, also for the organ failure. So this is due to the side effects of the drug, that anti-cancer drug we injected in the patient's body. So the main purpose of this nanomedicine technology is nanotechnology, that you have the medicine and you kind of packed in a delivery system, and the delivery system is formulated in such a way that it will target only to the tumor, and it will not interfere or minimal interference to the healthy cells. That's called targeted drug delivery, and then therefore treatment of the cancer. So we can have this drug delivery system like polymer based, from the polymer, you can wrap up the anti-cancer drug and then deliver. Or also you can have polymer coated metallic nanoparticles. And this metal can be iron oxide, cerium oxide, gold, and as you can think of. But we select the metal thinking of their additional property that we can use during the treatment. Like if I take iron oxide, this is the magnetic particle. Iron oxide is the magnetic. So you can have the MR imaging, MRI, MRI. So that you can see, you can monitor the drug delivery, and then you can monitor the treatment of the cancer. So we take advantage of the metals in string, properties. So today I'll talk about more focus on the polymer synthesis and how we can fabricate those polymers to the nanomedicine. So when we're talking about nanomedicine, the word nano comes and it derived from nanotechnology. And students, and we always think of nanotechnology. So I'll take this one slide from my classroom. And what is nanotechnology? It is the understanding and control of matter, like any matter like copper and anything, at dimensions between 1 to 100 nanometer. It can be 1000 nanometer, but for our nanomedicine application, I try to stick within 100 nanometer, where the matter, whether it is copper, gold, iron, exhibits unique and enhanced property. There are many ways I explain this in the classroom to attract my students to the class, their mind. But this is the kind of brief, definition of nanotechnology. Let's visualize this. How nano means how small it is. So we know, like classical Newton physics, where we are talking about galaxy, big things like galaxies, planets, and big car, the ball, the dust particles, the water droplets, everything we are talking about in the macro scale, like more than 1000 nanometer, more than 1000 nanometer. And there is another one we can think of the extreme left. We're talking about atoms, right? We're talking about quantum mechanics, like in the Armstrong level, like less than 1 nanometer. So you can just visualize the big part and the tiniest part. And I'm talking about like this, between this 1 nanometer to 1000 nanometer. And in our, particularly for the nanomedicine, 1 nanometer to 100 nanometer. Let's give you one quick example in the real scenario. If I say single wall carbon nanotube, I'm aware of it, many of us, but may not be everyone. So let's take, that is 1 nanometer diameter. So let's take one hair from the human hair, and then if you dissect, from the diameter, like dissect 100,000 times, the one time each of them part will be 1 nanometer. So you can think you're taking one hair, and then there's a so tiny diameter you can't see much, and you have to like dissect 100,000 times, and each time is the 1 nanometer. And we are talking about 1 to 100 nanometer, such 100 nanometer for the nanomedicine and for the drug delivery application. So that's the nanotechnology a little bit. So that when I say nano, so at least we're talking about tiny particles that we successfully synthesize in our lab, and then we use them for the treatment of cancer. So drug delivery systems, it is known in the literature that scientists are trying to wrap up the toxic anti-cancer drug in the in the polymer, but they are, most of the time they're using linear polymers like this. So when you have linear polymers, you have very less cavity. So the drugs, they will be falling out, and they have very less number of functional groups on the surface. They have only extreme, they have these kind of functional groups. But when you talk about functional dendritic polymers, whether it is hyperbranch or dendrimer, then you can see a lot of cavities where you can encapsulate drug, and then you have a lot of functional groups on the surface that you can decorate with the receptor target molecules to target the tumors in the patient's body. So let's talk a little bit about chemistry, polymer chemistry. Branched polymer, there are two types: hyperbranch polymer and dendrimer. Hyperbranch polymers are, it's like one-step synthesis. You can say if you have monomer ready, your monomer has to be branched. So we'll talk about that. So then from there, it's only one step. So total, it's maybe 3 to 4 steps to get hyperbranch polymer. You can see there's a stroker-like structure, 3-dimensional. You have a lot of pockets, so you can encapsulate it and do a lot of stuff. On the other hand, dendrimer is the perfect structure, so no defect in the structure. You can see if you start from the core, you can equivalently, you can grow towards the periphery in each side. So it's the perfect structure. But the pain over here is, it's not the pain, the hard work over here is, it takes more than 10 steps or maybe more. I will give you one example very quickly, how much it takes to synthesize few milligram of this dendrimer. So when you are talking about a lot of nanomedicine and a lot of cancer patients in this world, dendrimer becomes like less practical. But I'll give you one example so to know. By the way, these two structures are created in our lab. So this is good to know that, and I'll give an example how we synthesize that. So talking about the dendrimer, let's see why that is so difficult to synthesize. Because we synthesize dendrimer in stepwise process. It's called divergent growth approach and convergent growth approach. Maybe you heard about it in the organic chemistry or polymer chemistry class. In the divergent growth approach, you start from the core and then grow to the periphery. This is a one layer, means one compounds, the structure, that arms that you are adding and creating this three-dimensional polymer. On the other hand, for convergent growth approach, what do? You first create the periphery, the side arm, and then take 3 of them or 4 of them and then connect to the core. And then you use the converge to the core convergent growth approach. That's how we remember. So I'll give a quick example. I don't want to go through all the steps. It will take 1 hour. So I'll take one example quickly that what we did in our lab. So this is a perfect aliphatic polyurethane dendrimer with the allele groups on the surface, and we synthesized this using convergent growth approach. How? We started with the bis MPA, bis methyl propionic acid, and then we protected the alcohol groups with the allele groups, and then a series of organic chemistry. Now, there is 2 steps, there is 3 steps. Just all like a lot of steps inside, and to get from first generation to second generation dendritic ways. And then so forth, you can go repeat these steps to go to third generation. So you can see you started from here, and then you are growing, increasing the wedge, size, first generation, second generation, third generation, and then you can go further to fourth generation, and then you can choose one of these core, and then ultimately you can get a structure like this. So this kind of third generation dendrimer, and we do a lot of characterization techniques like NMR, multi-top, mass spec, FTIR, and so on to characterize them. So now from here, what I want to say, my message over here is dendrimers are beautiful, but it takes time. It's a lot of steps. The stepwise synthesis to synthesize few milligram of dendrimer. So to think about the practical world, we should go to the hyperbranch. However, having with this dendrimer in hand, I try to encapsulate abiraterone is one of the prostate cancer drug, and with the ITC, isothermal titration calorimeter, so that it has huge binding capability with the abiraterone in its pockets. And the experiments show that it has 3 kind of binding constant. It seems like this is 1, this is 2, and this is 3 binding sites. So 3 binding constant. Exactly not. This is 1 type of binding site. Here is another type of binding site, and here is another type of binding site. So that's how we visualize. So this is something that's coming. One derivative of this paper is just accepted few days back. A small part of this work, and then the complete work will be coming in few months after we hear some proposals going on. So anyways, so now I'm switching the gear from dendrimer, perfect structures, beautiful, from hyperbranch structure, which is random. You can see from here, if it is your monomer here, and if you lie down there, and this randomly grown in 3-dimensional way. However, at the end, it is giving you 3-dimensional structure and may fulfill your purpose of packaging the drug and delivering to the tumor site. I'd like to take this opportunity to introduce Seva Therapeutics. This piece of work is patented and then licensed by Seva Therapeutics, a startup company here in US. And now we raise some millions of dollars, and then we are actively working on this polymer, therefore drug delivery system, and going to the clinic to see this nanomedicine in the market. As I said, nanomedicines are not yet in the market because of the FDA rules and regulation, and we are trying our best to bring it to the market so that we do not have so many patients dying from cancer due to this non-specific treatment of cancer. So how to synthesize that? Students will love this. So this is diethyl malonate, where you can see there are 2 proton chemically equivalent. So you can plug off one of the proton and put bromobutyl acetate. So having this is called kind of AB2 system, and then you can hydrolyze it. You get the perfect AB2 system or A2B system, A for acidic and B for basic site over here. So, and then when you polymerize this one, you get a hyperdense polymer. See how easy and quick to get hyperdense polymer. So this is protected, this is patented and then licensed by the Seva Therapeutics. And then we do a lot of characterization. This is showing the GPC before and after applying vacuum. So how kind of good dispersity polymer we get it here. I'll switch from polymer to nanomedicine. How to formulate polymeric nanoparticle from polymer. This is also solvent diffusion method. This is also patented. And you can see this polymer has a lot of pockets as I shown. And then you have like drugs, like anti-tumor drug, and you can have some imaging agents like optical dyes for optical imaging. You want to see where the how the after treatment the tumor size is reducing or not, something like that. So all these are generally they're hydrophobic. And this polymer also a little bit of hydrophobic. So due to hydrophobic interactions, these drugs and dyes, they will try to encapsulate in the cavity because the cavity is hydrophobic. So it's called hydrophobic interactions. And it becomes more beautiful when you try to drop this polymer and drug solution in DMS, so both are soluble in DMS, so in water. Because at the end, we want medicine in the water because our body system is water. So we want to see our medicine is stable in our body system in the serum and PVS. So the beautiful thing of this solvent diffusion method is we do not use any surfactants, which kills cells. So this is surfactant-free, soap-free, completely water-based synthesis. And then with the established protocol, we were successful in loading or encapsulating drugs inside the polymer cavity, and where you can see a lot of functional groups are on the surface and helping you to conjugate with the receptor targeting molecules. So again and again, I'm saying receptor targeting molecules, and you are thinking, what is the receptor targeting molecules? So we'll come to that. So functionality in the core, that means what are the things you can encapsulate in the polymer to make this polymeric nanoparticle. You can have optical dyes, you can have therapeutic drugs, cancer, for cancer, chelated metals for imaging, like you can have gadolinium for MR imaging, you can have iron for MR imaging, you can have iodinated molecules for like X-ray CT contrast, right? And these are kind of some of the examples of optical dyes that is suitable for optical imaging, and see how they look. These are DII, DID, and DIR loaded nanoparticles. So nanoparticles are like milky solution. It's not transparent. If it is transparent, they precipitate it. If it is milky, that means there is the dispersion. Nanoparticles are never soluble, or most of the time they are not soluble, but they are dispersible. So you can see there's a milky solution, and based on the color of the dyes, they're encapsulated inside, and the color of the nanomedicine you get. And then we dialyze to get rid of all the free metals, drugs, and dyes from the nanoparticles. And then we do series of testing, how they look in the TEM, and the size in GLS, and their stability in FBS, in PBS, and then fluorescence studies and everything. This one I was saying, if it is only dye, or if it is just a physical mixture with the water, then you will see that it's transparent. It's transparent, so it's not the nanoparticle, but the nanoparticle would be like milky solution because they are dispersed. Now we're talking about functionality on the surface. So if you see here on the surface, if we have carboxylic acid, so we can do a lot of carbonate chemistry and put some functional groups, and then you can do click chemistry, is very important. And then you can do folate. You want to put folic acid on the surface. So you can have like from carboxylic acid, you can have aminated, you can have folate. So why folate? Some of the tumors, like cancer in our body, they overexpress some of the receptors. And then those receptors we have to target. So we need to have receptor targeting molecules. For a lung cancer, it overexpresses folate receptor on the surface, and the folate receptor binds with folic acid. And that is the reason why I'm putting folic acid here. And then folic acid will go and target to the folate receptor. So therefore, this nanoparticle with drug inside will go to that tumor and will not go to the healthy cells. Let's talk about this, the targetability. So here in the two panel, here 1 and 2, how to read those cell structures, maybe you know that, but the blue are the nucleus of the cells, and the red means this is the cytoplasm area, where the nanoparticle went in and released the dye, optical dye, red optical dye, that's why it's red color, and then release the drug also. So any cell, whether it is cancer or normal, their surface is negatively charged. And having these carboxylic acids on the surface, they are also negatively charged. So due to the negative interactions, repulsion, they do not go inside, or minimum. You cannot restrict 100%. They will go, but hey, it is better than 100%. If it goes 20%, I'm still happy, but it is better than 100% going to the healthy cells and dying for the side effect of the chemotherapy. And if it is aminated, so it is positively charged, and both cells are negatively charged. So due to the ionic interactions, it will go to the cancer cell. You can see that they are red, means nanoparticles are in the cytoplasm, and also in the healthy cells. So it's not good, it's not targeted. So that's why we need to conjugate. It's called nanochemistry. So you learn nanochemistry, nanotechnology, everything in one lab, from synthesis to nanotechnology, and then it will come to the drug delivery. So we kind of put everything together, apart from nanosensing and infectious disease. So a lot of things going on in the lab. So you can see when you have the folic acid on the surface, however, F549 cells, which is the lung carcinoma, that overexpress for a receptor, but minimum expression on the H9C2 cells, which is the cardiomyocytes, like heart cells from the rat. So you can see how targeted delivery can be done. You can see these nanoparticles can go selectively to the cancer cell, not to the healthy cells. Therefore, you minimize the side effects, and maybe you get cured. And when it's targeted, another thing other than the side effect, minimizing side effect, also your dosage to the tumor will be higher. So the probability of your getting cured will be more faster. So, and these are some other IVs, in vitro or in vivo imaging system that we confirm that where the nanoparticle going in the tumor cells or in the healthy cells. So we also take one step ahead for the preclinical studies. We take the mice and then we inject in their tail and sometimes in the eyes. I feel sad about that. So I prefer injecting in the tail. And then you can see this is our cancer tumor that we actually inject the tumor cells, the tissues in the flank. And then we grow there, and then we put our nanomedicine here, see it's targeted or not. By the way, this elevation here, it is the healthy cells we injected. You can see this is the healthy cells. There we can see how much targeting here. And this is like both sides we injected tumor cells, like a positive control. So you can see having the folate receptor targeting molecules on the surface actually helps for the targeted delivery and hence effective delivery. We can target many cancer cells, not only like lung cancer. We can go to the breast cancer, we can go to prostate cancers, many things. And this is one of the this is actually for the from molecular pharmaceutics, and it is targeting the breast cancer cells. We injected in this is the body of mice. And then you can see if you have an empty nanoparticle without drug, you can see with time, day 0, day 2, and day 4, the size of the tumor is increasing. However, if you have the drug, in this case, we used our own drug, CT20P is a peptide, then you can see the size of the volume of the tumor is reducing, which is fantastic. And then I think that's why we are moving. The company Seva Therapeutics who are very interested and approached us and then licensed and going forward. So now, as a chemist, you don't stop your research. You try to develop more and more and more and see what next with this. I mean, jumping from here to here, it's very easy, but working with one system and develop that technology more and more, that is the real science. Then doing another polymer, another polymer. We do, but this will be good. So I thought, okay, can I encapsulate bismuth DOTA complex, and it will be a nice X-ray contrast. I encapsulated using solvent diffusion method, but unfortunately, you can see the X-ray contrast is very, very minimal. Okay, so and this is the OmniPAG is the clinical standard. You can see we're expecting like this, and that means the bismuth is super hydrophobic and could not hold in this moderate hydrophobic region because you have oxygen and everything, kind of amphiphilic interior. So you can see then, as a chemist, oh, we have another hydrogen left over there in our synthetic route, right? We can play with that. So as you thought, and as we thought, I tried to put sulfur in the cavity by going through this route. And you can see when you compare, this is a second generation HBPE, and then you can see the difference in the structure. Now sulfur has the affinity towards bismuth, right? So this may end up giving contrast. So after doing a lot of characterization like NMR here, and then nanotechnology, nanomedicine formulation using Taxol as a drug, bismuth dotan encapsulation with Taxol co-encapsulation, and then putting folate, and then doing some characterization over here, and then do again, see everything is looking good, or targetability and everything, and it's killing, yes, with Taxol, it kills the cell. So these healthy cells, like there's no Taxol, no drug, so cell looks happy and healthy. And when you have the Taxol drug in the nanoparticle, you can see how weak they are. So move on, when we took this nanoparticle and give it for the X-ray CT contrast, you can see hypervalence polymer with sulfur pendant giving a very high contrast. So having this polymer with bismuth, this nanotechnology not only deliver and treat, but also give you the X-ray modality to see the treatment and see the how the tumor volume is reducing. Okay, so I'll finish this, maybe the second last one, I think. Yeah. I said polymer and polymer coated, right? So I just took one slide, last slide. The polymer coated, I'm talking about iron oxide nanoparticle. We can do the same. We can take our own polymer and then make iron oxide nanoparticles. They're super magnetic. And you can see the polymer coating is there. In the core, you have iron that gives MR contrast. MRI, you can do MRI with that. So with the MR contrast, you can deliver also drug and dyes, and you can do the same thing and same kind of MTT assay with a lot of assays, cell-based assays, and then we deliver and then kill cells and kill the tumor. This ferrahim, this is one of the FDA-approved iron oxide nanoparticle solution formulation that FDA approved. If someone is having like a less iron content, hemoglobin, less hemoglobin in their blood, actually doctor inject or take the pills or injection in their blood system so that immediately they can elevate the iron level in their blood. So this is FDA approved, this iron oxide, and we have patent on this, and we're actually working with another company for the nanomedicine. But from here, another direction of my research starts, which is the nanosensing. I use this magnetic nanoparticle nanomedicine as a magnetic nanosensor for the detection of infectious diseases due to its magnetic resonance or MR modality, MR property. With this, I'd like to thank AKS University and Government PG College in Chuna. I would like to thank again Sayendra, hope you are there listening. And Chitrasen, are you there? Chitrasen?
Yes,
Okay.
yes. Hello.
Nice to hear
I am
from you.
also
Thank you very much. Thank you very much for contacting me and for this.
I'm also
Yeah. So
Thank you, sir.
yeah, thank you.
We
Yeah.
are highly privileged to listen to you. The PPT was very fantastic, and what I say.
Thank you.
Can we take a
So
question?
thank you, and yes, sir. You can take question.
I would like to have the
Yeah,
discussion.
here a question.
Mhm.
May I ask it?
Yeah, sure.
Yes, sir. Yes, sir.
The question is very simple and very applied value. I mean, how these polymer molecules that you have studied work at a molecular level. In a neoplastic cell you are talking about. Could you really establish any specific mode of action? How pharmacologically these molecules are important in terms of checking the rate of cell multiplication? This is what I just wanted to know.
This is fantastic question. When if you are into the pharmacology, and I have I received many questions like this when I go for conference and presentations. You can see that our polymer is actually polyester, so they are degradable in the low acidic pH, and God created in that way. Our tumor microenvironment is acidic, it's below 7, and our healthy cells are above 7. So they actually degrade. Now you're talking about the molecular level. When you formulate the nanomedicine from this particular polymer, they're not like this polymer. One polymer is like how much? 10 angstrom or like 1 nanometer or 2 nanometer. Our nanoparticles are like 50 nanometers, 75 nanometers. So couple of these polymers comes together and then try to package this drug in one position. Now we're talking about the nano formulation. So you have these tiny, tiny nanoparticles. There are many of them in 1 milliliter of solution. And that is the beauty of nanotechnology. Your dosage rate will be so high. Although your cells, your tumor cells are multiplying is like a nuclear fission, right?
Yeah.
It's like multiplying. But remember your dosage strength. You are giving 1 milliliter, injecting only 1 milliliter. In that 1 milliliter of your nanomedicine solution, you have billions of nanomedicine. And in that billions of nanomedicine, nanoparticle, inside you have a lot of drugs in one of such nanomedicine. So actually the dosage level is so high. Although
Yeah.
the cancer cells, tumors are growing very fast, so but still it will do. And we have a lot of data with
Okay.
respect to the preclinicals, like mice models. We also went ahead to the monkey model, but now we have money. So going to talking to the doctors and hospitals, who the patients who can give the authorization to use on them. Generally,
Okay.
in a fourth stage, patients say, let's try a new system. So that's what we are doing right now. Thank you for the question.
So do we really have any comparative rate of their efficacy of various polymer nanomolecules applied so far? Comparative
Uh,
rate of efficacy.
Efficacy, yeah. So the efficacy, there are two, like the dosage efficacy and the treatment efficacy. I think you are talking about the treatment efficacy. At least 10,000 more than the molecular nanomedicine. At least 10,000 more higher efficacy, 10,000 higher efficacy than if you inject a small molecule like Taxol in the body. Not only that, why that is 10,000? Because it is targeted. And now if you talk about the market, why it is not in the market? Because of the FDA. FDA wants everything. In the United States, the regulations are so tough and so good also, because they want everything is precise. They will always ask you how precise your nanomedicines are. When you're
Okay.
talking with the polymer,
Okay. Okay.
precise
Okay.
size getting is very difficult. Yeah.
Thank you. Thank you. Thank you very much.
So, thanks. Yeah. All
Thank you,
right.
sir.
I'll unshare. Thank you.
Any more questions from
No,
anybody?
no more from my side.
Okay. Okay. Thank you, sir. Sir, please stop sharing.
Yeah.
Yeah. Okay. Thank
Prasad.
you, sir. It was very nice presentations. Now going ahead to our next speaker, Dr. S.P. Singh. Dr. S.P. Singh, Dr. Surya Prasad Singh is a principal scientist at Polymers and Functional Materials Department, CSIR, Indian Institute of Chemical Technology, Hyderabad. He studied chemistry at the University of Allahabad, India, and obtained his PhD degree in 2005. Later, he joined CSIR, Indian Institute of Chemical Technology, Hyderabad, as a research associate. After working at Nagyo Institute of Technology, Japan, as a postdoctoral fellow, he joined Osaka University in 2008 as an assistant professor. He worked as a researcher at Photovoltaic Material Unit, National Institute of Material Science, Tsukuba, Japan. Recently, he worked as base fellow at University of California, Santa Barbara with Professor Bazan Research Group. He has been involved in design and synthesis of functional conjugated small molecules for photonic devices, sustainable dyes for textile, photoredox catalyst, and published over 180 papers, reviews in peer-reviewed journals and patents, edited 2 books, and author of 1 book chapter. In the list of his awards, he was awarded by Fellow of Royal Society of Chemistry, AVRA Young Scientist Award 2015, Bhaskar Advanced Solar Energy Fellowship by Indo-US Science and Technology Forum to Work University of California, Santa Barbara, Young Scientist Award by the Council of Science and Technology, Government of UP, CSIR IICT Gaurav Samman conferred by CSIR IICT Hyderabad, Associate Fellow of Andhra Pradesh Academy of Science, Young Scientist Award conferred by CSIR ICCT Hyderabad. Nasi Young Scientist Platinum Jubilee Award by the National Academy of Science 2012. Welcome, Dr. Surya Prakash Singh. I welcome
Thank you,
on
madam.
behalf of AKS University Chemistry Department. It was highly privileged to see your long list of awards and honors. So, floor is all yours.
Thank you very much, madam, for your introduction in detail. So, is I am
Yes, sir.
audible?
Yes, sir, you are audible. Please
Okay.
present yourself. Yes, its PPT is visible.
Yeah, thank you very much, madam, for your kind introduction, and thanks inviting
Thank
me
you,
here.
sir.
Both the organizers, particular my friend Dr. Subedar. I'll be presenting on our recent achievement on energy materials. Basically, we are chemists and we work on the development of light harvesters, such as a dye molecule, functional conjugated dye molecule, which can be used as a light harvester, and we can harvest the light from sun and produce the energy. And we use our chemical technology like chemistry as a tool to develop those kind of products, such as CC coupling reactions. Also, since it is a dye molecule, so we don't only work on the energy application. Since it is a colorful, so it can be utilized for many applications, such as coloring of the textile material, flexible devices. Also, I'll be talking about how this organic molecule is better compared to the existing materials such as silicon solar cell. So my topic is a small molecule for sustainable energy, development of photonic devices and beyond. Beyond means these all the developed molecule, how we can use not only for device, for other application. So my introduction deals with the one technology. It's called dye sensitized solar cell. I'll be talking about dye sensitized solar cell and how it's a function and it's a working principle. Then organic solar cell. The organic solar cell is different from the dye sensitized solar cell. They're electron donor and electron acceptor. These are the organic molecule. It mixed together and form the active layer, and we can make the device. Then perovskite solar cell. In perovskite solar cell, we will be working. I will be talking about how to develop a new technology which we can make for the large area of the solar cell. And finally, summary. Here, this slide is the deals with our group activity and some of its representative publication, such as OPV, organic solar cell is one area where we are working. Dye sensitized solar cell is another area, and then perovskite solar cell. And also we work on the conductive ink. What is the conductive ink and why this conductive ink required, and it's related with these two components. I will tell you. Conductive ink means we can make it for the flexible devices, like device which can be folded. We can fold it and we can print it. For that, conductive ink is required. Then before this is our humanity top 10 problem for next 50 years. This is before the COVID-19. That time energy was on the top. Even energy is required, even at present time also. So energy is on top for the top 10 problems for the next 50 years. This is the global data. Then the energy industry and its ecosystem. It is divided into the two sections. One is the non-renewable and renewable energy. Renewable and non-renewable. In the non-renewable, it's a coal, oil, gas from the natural sources. And if we have the coal, oil, gas, we are utilizing it, and after some time it may deplete. So we don't have. And renewable energy, solar, wind, biofuel, hydro, and other. I will be talking about the solar energy, which is our core research area. The energy consumption by the US and American data this is, and where is the now people are consuming. If you look about the renewable from the across the globe, only 2% utilization of the renewable energy in 100%, which is very less, and mostly it comes 40% from the coal. As I say, coal, it may deplete after some time, so we have to look for the alternate energy source. Then next is the gas. 19% energy coming globally for the from the gas. Nuclear energy, and that's 16%. Just next to the hydro and coal. So nuclear energy is good. The most of the developed country, even our country, we have the nuclear energy. It's a good, we can get the uninterrupted power and energy throughout the year. However, once a natural disaster it occurs, it cannot sustain. I will tell you one example where I am the witness of this nuclear disaster. If you all remember, in March 2011, there was a big tsunami in Japan, and I'm the victim. I was there, and then there was a Fukushima nuclear plant. It blasted actually, and then people, they moved. Still about more than 30-kilometer radius is still, it's sealed. So nuclear energy is good, but once natural disaster happen, then it cannot be control of this because it use a lot of radioactive material. Similarly, long back it was Chernobyl in Russia. Because of the natural disaster, the nuclear plant, it blasted. Then, being a responsible country and citizen, we have several other international norms. We have to follow it. And in global summit, it was decided how to reduce the carbon production. Because, and by 2030. So there are several agenda internationally made, and it was decided that how to reduce this carbon dioxide. And mileage is one. And if earlier, when the automobile, it was giving less mileage, and now we have good mileage automobile, good mileage vehicles. Earlier, 1 liter, we were used to have at least 14 to 15 per kilometer or 10 kilometer, but now we have 20 or more. So mileage means we are burning only 1 liter, but our mileage is more. So it is energy efficient. Energy devices which can give the high efficiency, like we have 20%, so we should go for 30%. Lighting, ACs, industrial motors. If you notice, earlier we had a filament bulb, and then it came the CFL. Now we have the LED light, because it consumes very less energy, and government is also giving the subsidy on it. And then same thing, ACs. We have now the window AC, now have split AC, 5-star AC, inverter AC, because less energy consumption. That is another way. To the next one is the nuclear and renewable and biofuel. So these are the chart designed by the international norms, and people are trying to achieve this by 2030 to reduce the carbon dioxide. Then why the renewable energy? Because do not deplete the natural resources, because natural resources like sun will not deplete. We have the sun. Then global warming has hit, as we know, it's a public and political. And then effective method to reduce the carbon dioxide emission. Then guarantee of the security. This is guarantee for the energy security for the country who deployed it, and government also has passed the legislation for as a Jawaharlal Nehru solar mission for this. Then these are the key renewable energy resources, like solar power. Among solar power, photovoltaic and solar thermal. Wind power, it's onshore, offshore, and biofuel. In biofuel, there are several generations, like first generation, second generation, and third generation. First generation belongs to the agriculture crop, second generation with the cellulosic feedstock, and the third generation is algae, and then the hydropower. So based on their capacity and the availability, each government and the researcher, they are working on this kind of renewable energy resources. Here I will start my topic. What is this? Dye-sensitized solar cell. Dye-sensitized solar cell, it was inspired with photosynthesis. If you notice about our photosynthesis process in plant, then how the plant, they make their food with the natural dye, that's called chlorophyll. And then the plant, it survive, and it has different kind of, the color, because green color comes from the chlorophyll. Based on photosynthesis, this technology, it was implemented. It's called dye-sensitized solar cell. Also, it called sandwich solar cell. Then what is the sandwich? Sandwich means egg bread niche, egg bread upar, beech mein masala. So in between that masala is nothing. It's a dye molecule and ingredient. I'll be talking about what is this sandwich solar cell. And we can see with this cartoon, one is here. It's called TCO glass, and this is counter electrode. Another slice is one slide down, one slice up. In between this ingredient, that's masala, that's the dye and TiO2. and electrolyte. So these I will be talking about how to make a sandwich solar cell, and this is very good technology because it works under diffused light. Diffused light means with this we can install in our room, in our laboratory, in our hall, because it is not mandatory that this device should face towards the sun, whereas the commercial silicon solar cell, it has to face towards sun, and when sun rotate we have to use the solar tracker because our panel should also move according to that sun rotation. The working principle here, you can see this cartoon, how electron is coming and going. Any molecule, once light fall on that molecule, we know its electron get excited. It means it goes from ground state to excited state, means HOMO to LUMO level, and then it come to again it stays certain time, with transient that lifetime, and then again it come to the ground state. But once it come to the ground state, the lifetime of electron, that cycle is over. But here what we are doing, we are using the redox electrolyte, and again this electron is regenerating, and then continuous we are getting this cycle, and then it producing the current. This is a simple technology. And here this is one ruthenium metal. It is used so far as the best champion photosensitizer, this ruthenium dye. This ruthenium dye structure, the chemist, they can easily understand 2 bipyridine connected with the ruthenium metal and 2 NCS group, thiocyanate group. The merit, it's a low manufacturing cost, very cheap material, colorful and flexible. The flexible means because it works under diffused light, it is not required to face towards sun, and it can be folded. And how I'll show the further, as I mentioned, it's a transparent, colorful, flexible, easy purification process, and there are so many other advantages. These are some devices. Here one, the transparent, we can see from this side to that side. Here is one window. We know window is unutilized area of our house or our offices. It just protect the heat, the dust and privacy. So can the window also use to produce some energy to light at least one light for our room? So if we have such kind of technology, we can harvest the energy from outside, and we can at least one light, actually one bulb, one small bulb we can lit. These are some flexible devices here, it presented. Then how it's colorful, we know the chemistry. Once we change the chromophore, and we can change the color. So different kind of chemist knows they can play the with the color. Just change the chromophore and change different kind of color. I'll show here. If someone want to do research, then what are the guidelines, how to work in this direction? So there are 4 major components. One is TiO2 and dye, electrolyte and device. I will be today talking about the dye molecule, how a panchromatic, what kind of dye is good for this dye sensitized solar cell. This, as I said, it's a black dye, red dye here, 2 bipyridine, and below that you see this is so it's a BG slide. I'm sorry, actually. Here you can see the solar cell spectrum, that red color. This is the spectrum of sun. So with principle, if we have any dye molecule which shows its absorption parallel to sun, it means we are harvesting all the photons present in the sun, and then we can it can be generated at energy. That blue line, blue curve, you can see the desired one. But across the globe, people are working in this area. You can see we could able to harvest up to this much, this green one, only this much from the sun. So one can develop a panchromatic sensitizer. It means which shows about IR absorption to harvest all the photons from the sun. Based on this, our methodology and concept, we try to develop few sensitizer. You see here DCBIQ, DC-biquinolin, then monobiquinolin, and you can see here DCBPY, it is a bipyridine. So based on this 4 complex, we made the complex. And here you see the right hand side below, with bipyridine we can get absorption up to 330 nanometer, 530 nanometer with pyridine quinoline, 580 nanometer, and B-quinoline 625 nanometer. So based on the concept, if you see 625 nanometer absorption is good, we can get very good energy from this. And then we made the device using this complex. Further at last, if you see this IPC spectrum, the pink one, there is no current, though absorption is 625 nanometer. Now one can ask the question, based on my concept as I described, it should give the highest efficiency because the absorption is 625 nanometer. But when we made the device, the pink, please notice here at the pink one, there is no any current. If no current, then where is our concept? Then we studied very deeper that what is the problem, why this concept is not working. And if you see this HOMO-LUMO chart here, that yellow our mark, this one HOMO-LUMO chart here, the HOMO is minus 5.6, electron volt and HOMO this, and in here left hand side is the CB, that is called the conduction band, and INJ means injection. So if we have the HOMO, once light fall on this our molecule, it goes to the LUMO, excited state. If the LUMO is below the CB, conduction band of the TiO2, then electron injection is not possible. So we cannot get the current. So it is not only that only the high absorption, high absorbed molecule give the high efficiency. No, it should fulfill the redox properties also. Like its LUMO level should lie always below the conduction band of the TiO2, then only electron injection is possible to get the high efficiency. And if LUMO is below CB, we don't get current. Here one example of color, you see the yellow color of the device. This device was made in my lab. This 3 bipyridine, 3 bipyridine, yellow color, this red color 2 bipyridine, and this is the terpyridine, tripyridine, 1 to 3 terpyridine. It is giving the red, sorry, black. Here it looks a blue, green, but it's a black. Based on this, we have synthesized a series of metal complex, more than actually 4 dozen. But here I will show only one example because this is not the forum to explain all. This is the black dye. It is commercially available from the different company. And we have done a small molecular engineering. At one pyridine, we have installed this 4-methylstyrene group. It looks very easy, but synthesis was really took longer time by see the functional group tolerance property of this carboxylic acid. When we install here 4-methylstyrene group and we name it HIS2, and the IPC spectra you see with the champion dye, like black dye, the blue one, here we are getting one V shape. It means this much energy we are losing, whereas our HIS2, our molecule, we are able to harvest all light, and the device shows 11.1% efficiency, which is very high for the organic molecule, and with the black dye 10.5%. This was published, and also it came in a Nature News also. I'm not showing here. So this is the so far the one of the best champion sensitizer, and based on this, a few of our representative metal complex I'm presenting here. This slide will show that some of the good ruthenium complex here. Again, now, as I say, this device is, this solar cell technology is very cheap. Now, one can ask the question, how it is cheap? We are using the ruthenium complex, and ruthenium metal is not cheap. So how we can claim it's a cheap? Considering this, we have moved our next objective to develop a simple organic molecule like the photosynthesis, like the small organic molecule. We have developed a simple organic molecule here. The series of new small molecule we have synthesized. This also shows equally good power conversion efficiency based on the different kind of dye. You can see here porphyrin dye. We know that porphyrin, it is in our blood, that heme. Here is the porphyrin, triphenylamine based, AK01. You can see here indoline based. Again here the diketopyrrolopyrrole based. The concept here, what I would like to mention, you see in the middle, organic photosensitizer, that green color, our text, we have used the push-pull kind of concept. donor and acceptor. Push means one side it will push, and here the cyanocarboxylic acid, that CnCO2H, that will connect, that hydrogen bond, it connect with the TiO2 and it will give. So based on the push-pull kind of concept, we have synthesized all our organic molecule, and this organic molecule tell us we don't require the ruthenium complex. This organic molecule is good to harvest the light and in a less expensive manner. So efficiency, I mentioned, we have got the about over 11%. So we thought, can we go with a new concept to harvest the more light and more energy? Now you look about this, the another solar cell spectrum, here it's the same. So as I say that our desire is blue, but we could able to harvest up to this green one, only this much, this V shape you can see here, one dip and this dip. We thought, just see the next, our light harvesting efficiency. Can we use two dye? One dye shows up to 300 to 700 nanometer. Another dye is 700 and beyond, about 12, 1100, 1300. So we can harvest all the photon present in the sun. Based on this concept, we propose here, and you see the IV characteristic. If one have here and one is here, so double dye cell, we can harvest maximum. IPC spectrum also, you can see dye 1, dye 2, and we can get the maximum. This is our concept and our research plan we implemented, and we assume that we will get the 20% efficiency, because two dye, it will complement each other and we can harvest the photon. Based on this, we mixed one metal complex and one organic dye here, and you see here simple dye. See this, our table here, TDP is giving about 4.8% efficiency. When we are mixing the another SPS1 and we are getting 8%, please note here, this is not for the high efficiency, that we are not working to get the high 20%. This is just to prove our concept, where single dye and double dye concept is working or not. So therefore, efficiency is not matter here. Here we wanted to know our concept, and concept perfectly it works, and we have I think more than 24 paper on this kind of concept. And you can see also the next one, the SPS1 and different JD1 dye, the second part, metal free dye containing thionyl fluorine conjugation. Similarly, if you look about the table, we are getting, when JD1 is showing about 4.7%, when we are mixing we are getting 8.3. It means our concept is valid, and based on this one can produce the highest efficiency by choosing the appropriate photosensitizers. The another thing, everyone can make the dye. Any organic laboratory, they can synthesize the dye and develop the new. But purity is very much important. Here,
Excuse
one
me,
example. Yeah.
Excuse me, sir.
Yes.
Yes, sir. Please, we are running out of time, sir.
Okay. So how many
Hello?
minutes?
Yes,
How many minutes I can spend?
Five more minutes, sir. 5 more minutes.
Okay. So this is one concept where we are working on the purity. This is one about the transparent solar cell. As I say, how we can utilize. Whoever been to ICT, they can see this is the transparent dye, and we have built up this device, and you can see our institute. We can see from this side to that side, and we have developed a series of new color, so it gives a very aesthetic look. We can provide a different kind of look, and we have used the simple CH activation chemistry, and you can see here once chromophore change, color is changed. So unutilized area like window also, and we are getting 9% efficiency based on this. So unutilized area like window, we can make curtain also out of this. Coming to the next technology, it's called organic solar cell. Here electron donor, electron acceptor is used, and we can see here polymer, and the electron acceptor is fullerene. The advantage is it can be printed as roll to roll, and the disadvantage is fullerene is very less soluble, and polymer gives a batch to batch variation. Like one batch gives like 12,000 molecular weight, next batch may give less or more. So we will replace polymer with a small molecule. Here is the concept. We have developed the several small molecule. You can see here. Mostly the stellar coupling we have used to synthesize these molecules. Since we don't have time, so I cannot explain a lot. Just I'll go through it. And this work I worked with University of California, Professor Bajan and Heger. He got Nobel Prize during 2000. So I was fortunate to work with him, and you can see here we got about 9.1% efficiency. And this is our lab. We have developed a series of different kind of organic molecule with various efficiency. These are the synthetic. Now donor acceptor we are mixing together. So we thought, can we synthesize a molecule which gives the simple donor acceptor in one unit? Here is one we have synthesized donor acceptor, and the work was published in Chemie during 2016. Thus, we don't have to mix donor acceptor separate. This is only the one molecule. It works as donor acceptor both. There are a lot of actually good chemistry, but time is running, so I may not be able to explain in much detail. These are some fullerene derivatives we have synthesized because it's soluble, and few of them are commercialized. So some Japanese company, they are selling it. Interested can. Not only that, this is the commercially available, but it has a 5-step procedure, and we have developed a single-step process. And compared to the commercial one, this is the best. And these are the other molecule based on fullerene. But fullerene is, as I said, it's not soluble. So based on that, we have synthesized non-fullerene acceptor. Though it's organic molecule, but it works as a fullerene, so it can be replaced. So here are our synthetic step, and we are able to get up to over 10% efficiency. This is one. If 1 minute time, I can show how we are working on the paint. So can we develop the molecule or some light harvester which can be painted? We can paint it on the wall because we have a big wall, so we don't have to use extra land for the solar cell. So this concept we are working, maybe in some other forum I can present about the solar paint. These are the another concept, because perovskite is contain lead, so we want to replace lead with the lead-free perovskite, and these are the second half part is for the OLED. So how we can see here, cesium lead bromide, when we are doping with iron, we are changing the color. It's a dual emission, is very good for the OLED application and light emitting diode. This, as I say, for the flexible devices, I have a good video, but I may not show. This we have developed the conductive ink, and we have printed on the paper. You can see CSIRICT. This paper, we could able to get the energy, light. There is no wire, just we have provided the energy, and we can see. And our Science and Technology Minister also visited here. This project is very good for industrial. So we are working this project with the industry. These are some the demo when I was during my Japan. We had this dye-sensitized solar cell car race. We also participated. My photo is not there. Because I was taking the picture. Here, these are the flexible devices. As I say, these are with few industry. They have funded. We are working this for the dye molecule, flexible devices, and one for the forensic application. Not only this, we also work for the forensic application. You can see here there is nothing, but we have formulated the ink. You can see we have filled in the refill, and when we irradiate certain wavelength of light, we can see our text, what we have written. So this dye is not only for the solar cell, it works for several other security and forensic application. The dye for ink, you can see we have formulated the ink, and it is visible, and it is very stable even in water. So our dye, our ink is very stable even at 70 degrees centigrade for 1 hour. The blue ink, the yellow one. So organizer, if you feel, because it's still a lot of, so I will just stop here. So this is dye for the textile industry we are working. This is funded by the industry. Not only this dye, what I've shown, we have several other dye, because the dye generate a lot of effluent. So we are working that dye should not generate the effluent. It can be coated on the fabric like our cloth, and it is sustainable so that less effluent can be generated. So here I will just end my talk as my time is over, and I would like to thank all my students who work hard to get this result, and I thanks to my the directors, previous and present director, my HODs, and all my funding agency who fund to do such research. And finally, I thank you, all of you.
Thank you, sir.
Yeah, welcome.
One question.
Yeah, please.
Thank
Yes,
you, Dr.
sir.
Singh,
You may
for
continue.
thank you, Dr. Singh, for your valuable lecture on dyes.
Thank you, sir.
My very simple and good question is by utilizing the great characteristics of chromophores
Yeah.
in the dye molecule, we play with the colors of light.
Yeah.
Do we have any role of oxochromes in the molecule which can really play a greater role in harvesting the solar energy from a variety of dyes which are being used by you or studied by you? Did you ever use cyanine dyes as a energy harvesting molecule from solar sources?
We have used cyanine dye. If you look about, I showed about that transparent solar cell. For the transparent solar cell, if you notice that structure, it is based on the cyanine dye only.
So do we have any impact of size of the molecule or the nature of the chromophore or the degree of light absorption?
Size doesn't matter, but it should follow certain route, such as homo-LUMO should be appropriate and its absorption. If we have better absorption and follow the shows good redox property, then that's okay. Regarding the size, if we go longer size, it may require a lot of lengthy procedure to synthesize. So we believe that, of course, the size matter a lot, but smaller is best. That's why we say small molecule. If it's small, then synthetic utility is easy and it's a low cost. If you go for extent, there are many molecules we have synthesized large scale. I mean, large compound. That really the synthetic utility is not very handy. We have to spend a lot of time to synthesize that. So we believe that small molecule is better.
So any specific dye accepted to the level of actual application now?
Porphyrin dye is used for the several application actually for domestic use. It has come. This transparent dye which I showed, that is now those kind of dye. Entire Geneva airport, it has been used for the domestic application. If you visit the Geneva airport, the one company named Glass to Energy, they are our client. They have utilized this dye for the entire Geneva airport. They are harvesting and producing for domestic purpose, because dye sensitized solar cell cannot give that high level of the energy because the durability is so. But it's very cheap, so people are using for a small domestic application.
So any patent so far?
Oh, many patents, sir. We have, I think, 17 patents. Myself, I have.
That's great. That's great. Wonderful. Congratulations. That's great.
Surya Prakash, I am Professor A.P. Misra from Sagar. Hello. Namaskar. May I just know, you delivered a very beautiful talk, wonderful, many more things that I harvested as an inorganic chemist, just a sense of stimulation. Still, can we have some replacement for the ruthenium by some simple metal? So far, because you have worked a lot on this very area.
We can replace, before that, Professor Tiwari asked that, can cyanine dye work? So small molecule like indolene based molecule, triphenylamine based molecule. So we are completely working to replace the metal.
I'm asking as a metal, the replacement of ruthenium by any other metal.
मिश्रा सर आपका आवाज रुक गया.
रुथेनियम का रिप्लेसमेंट किसी और मेटल से पॉसिबल है क्या? लगभग एफिशिएंसी अगर 10% के आसपास हो तो.
People tried, sir, with iron and they have used a different kind of concept like zinc porphyrin. So that used, and zinc we have available plenty in our country. So zinc porphyrin is used, even our group that we have used. And zinc
yes. The zinc may be good because iron is not working well.
Iron is not working.
There is maybe possibility about the cobalt also if you have some experience. Otherwise,
cobalt, sir, it is used for the redox couple because solid state. So far, people are using the liquid electrolyte. And liquid electrolyte, because we get the recombination of electron. Because time I had very limited, so I could not explain the mechanism.
I shall ask some of your reprints and then I shall go through.
Yes, sir. Yes.
Thank you very much.
I'll just explain you. Yeah. Any more question? Participant?
Any more questions? Please stop sharing your screen. Stop sharing. There is an icon below. Stop presenting or stop sharing. Yeah. No, your screen is still visible, sir.
Yeah.
Stop presenting. There is an icon. Okay. Yes. So yeah, it was a great presentation, sir.
Thank you, madam.
Yes, sir. Hope there was a new knowledge for me for different kind of dyes and that solar cells. So I think most of the people have been enriched by the knowledge of these.
Second part was more interesting, but maybe some later, some next platform I can show.
Yes, sir. We will definitely give you another platform to show that, because we are running out of time. We have a list of speakers, and you can see that.
Yeah.
Yes. So on the next series, we have our next speaker, Professor Archana Pandey. He is working as a professor since last 15 years. Professor Pandey is head of Department of the Chemistry at Dr. Hari Singh Gaur Vishwavidyalaya Sagar. She is having additional charges of Director, Faculty Affairs and Chief Editor of Madhya Bharati, a central university journal listed in UGC Care List. She worked on nanoparticles. 20 students received PhD degree under her supervision. She also visited University of Washington, Seattle, USA, and also University of Arizona, USA. So, Professor Archana Pandey, welcome, ma'am, on behalf of AKS University, Satna Chemistry Department. Hello. Hello. Archana, ma'am. Am I audible to you? Archana, ma'am. Hello. Please unmute yourself. Unmute yourself.
Okay.
Yes, ma'am. Now, please open your camera also, so that we can. Just that icon is just beside it. That mic button. Just beside the mic button, that icon is there.
Just a minute.
Yes, ma'am.
All right.
Just open it. Yeah. Now you are visible. Yeah. Now
I'm visible.
Yes, ma'am. You are visible. Now you can share your screen.
How I can share my screen? Present now?
Yes, ma'am. Go to present now. Click on that present now. Click on your entire screen. Again, click on entire screen.
Sure.
Go to entire screen. After clicking your entire screen, you will see one dialog box will appear, which will show your window. Click on that, and after that, the share button will be enabled.
Yes, share button is here.
Enabled? Is it enabled?
Yes.
Just click on that.
But it is not working.
That's why I'm saying that. Just first click on that screen. Share your entire screen. Yeah. Click on that screen.
Right.
After clicking, that share button will be enabled. Yes.
Share button is present now.
Yeah.
Yes. This one is the present now.
Yes. Present now. Go to present now. Then go to your entire screen.
Yes. Then
After
share.
going to entire screen, then not directly share. Click on that window which is appeared before the screen. Just click on that window.
Yes.
Click on that.
Yes.
Yes. After clipping. Yes. Now you're. Yes. Now minimize the window. Now I can see your screen. Yes. Minimize your window and open your PPT. Yes. Open your PPT, ma'am. Yeah.
Right.
Your PPT visible. Just yes, it is visible now. Yes, you have to maximize the PPT. Yes, ma'am. It is visible now. Just maximize it. Maximize it.
All right.
Yeah, it's visible.
It's fine.
Now floor. Yes, ma'am. Now floor is yours.
Okay. Now my topic before delivering the my lecture, I would thanks AKS University Satna and Department of Chemistry for giving me this opportunity to sharing my views with all of you. My special thanks to Dr. Dinesh Mishra, head of the Department of Chemistry, for interacting me and for introducing in AKS University Sapna. Since I know that AKS University is running number of courses in the agricultural science, and therefore I have taken my topic, that is the nanotechnology in agriculture. This is not research oriented topic. This is a generalized topic. That's why everyone can understand this one. Either it may be a chemistry people or not belong to the chemistry department. Before starting my lecture, I will say few words about my university because yesterday we were celebrating the 75th Foundation Day of Dr. Hari Singh Gaur Vishwavidyalaya Sagar. This university is uh, founded by Dr. Hari Singh Gaur by donating his own property, own rights to the university. And in the right hand side of the screen, this one is the central library of our university, which is inaugurated by Prime Minister Pandit Jawaharlal Nehru, and the left side of the screen is the Department of Chemistry. The specific character of my university is that it is established before independence. So proud of the Madhya Pradesh that university is before the independence. Now, nanotechnology in agriculture science. It is also referred as the grain science. From fish to fungus means from a small house to a tree, from potatoes to people. Green nanobiotechnology is science related to raising the plants and animals to produce food, feed, fuels, fiber. Is about more than pesticide, genetic engineering, and so on. Now, whole nanotechnology is related with the a small plants to a big plant. Let me clear how a small science can do a big things. How it is a simple screen for your understanding how big is nano. 1 nanometer is containing number of things which is visible in slides. It is for a simple slide. The scale of the nanometers are here. Now the different size of the things are given for general introduction. Now, where is nanoscience in agriculture and food science? I have already told you that this is not research oriented. I am not taking in details. So first, we prepare the materials of the agricultures, and these materials may be nanoparticles, nanoemulsions, nanocomposite, nanostructured materials. And these materials are used in the agriculture science or the food science. Now, how to process these materials? There are mostly four methods to produce heat mass transfer, nanoscale reaction engineering, nanobiotechnology, and molecular synthesis. After the production of agriculture product or the pesticides, we we pack this one and deliver to particular site. The major thing is that how to protect, just a minute, how to protect these things. So the nanotechnology provides nanosensors and nano tracers. Now, the problem where the nanotechnology faces in case of the agriculture and food science, first one is the pathogen, which causes the disease and contamination. It is difficult to tracking the crops and the products. Nano devices for molecular and cell biology, nanoscale material science and engineering, environmental issue raised during the when we use the nano technology in the agriculture, environmental issue, agriculture waste, and if anybody knowing about the nanotechnology for the agriculture, people are the farmer are not aware about this one. So last duty or the most important duty is that to educate the farmer or the common people for this technology. Now, first one is the pathogen or contamination, which can be detected by the. Imagine using nanotechnology to create self-healing materials. Self-healing materials means the pathogen can be automatically destroy at that place, or coating that can modify agriculture materials, or packing to prevent microbial contamination. Another application of the nanotechnology is nowadays is used, that is the sensor, which earlier speakers are already discussed. So with the help of sensor, we can detect the pathogen. Now, with a simple example, I will describe how the nanotechnology is useful in agriculture and food sciences. Now, when the pathogen chemists are doing that experiments on the pathogen disabling nanoparticles to keep chickens healthy. How it is performed? Nanoparticles are added to feed and mimic cell surface inside the chicken. The tiny pathogen germs, because they are very small, they get confused and bind to the particle instead of the real cells. Then automatically they go through the PKPD or the digestive system of the chicken, and the chicken is safe and healthy. Now next one is on the other hand, scientists are working to find out the simple handheld instrument that can detect bacteria in 15 minutes using this technology. Nowadays, traceable nanotags and food quality sensor could improve food quality, taste, nutritional value, preserve food, and extended nutritional stability. Nanoscience in molecular and cell biology. Nanotechnology is making revolutionary changes within cell, which will improve agriculture and the food industry in amazing ways. Develop better soil additive, fertilizer, pesticide, and soil condition. Now, it is a very generalized word that develop better soil additive. But here, the methods are available to develop the soil additive, to minimize the use of fertilizer, to minimize the use of pesticides. Develop because when we increase the surface area, there is automatically less use of the pesticide, fertilizers, and the others one. Now, I will explain with another method. Identify new agriculturally derived molecule for industrial and biomedical applications. In case of the food, which is used in the which kids are used to say, no, it is not tasty, I will not eat. This one, it is a common practice in houses. So by using water, it is very useful for the heart patient also. By using water instead of oil in foods to reduce fat. Now, one question comes in mind in everybody that how the oil is replaced by the water, but the processes exist and researchers are doing it in this field also and creating texture that feel like high food in your mouth. and the kids are saying that, wow, it is yummy. I have taken one example of the ice cream, which is very frequently used by our kids. Now, only nanotechnology allowing oil to be replaced by water to make foods. When they replace the oil by the water, they increase the surface area. And when the surface area is increased, the reactivity is also increased. Like ice cream healthier, it is also developing low fat ice cream by decreasing the size of the emulsion particle. When we increase the surface area, the size of the emulsion particle will decrease, and it texture of ice cream is also beautiful, using up to 90% less of the emulsion and decrease fat content by 16% to about 1%. There are some nutrients which is available in the market, and it is very useful for energy intake also. Now, if you reduce the oil uh, by water, if you replace the oil by the water, means the energy is less required to burn up anything. As a result of the large surface area at the nanoscale, it can extend the useful lifespan of the oil, and it heats up more quickly, which reduces the energy required for cooking. So here you reducing the fat contents as well as the fuel also. Uh, uh, Now, nanomaterials engineering and material science and at the nanoscale is also improving agriculture and food industry, which I have already told you. Researchers are conducting research to better understand the mechanics of nanomaterials, such as self-assembly, like self-assembled capsule on the right. Here is the self-assembled capsules, developing nanomaterials using DNA as a building block, like DNA, nanowire, DNA microelectronics. If there are any environmental issues or agriculture waste, yes. Agriculture waste is a big problem amongst the farmers. Therefore, understanding the role of nanoparticles in organic in the movement of the uptake of the nutrients and pollutants, and the movement and toxicity of the nanoparticles in agriculture pollution, dust, flood, runoff, reducing or converting animal or plant waste into useful products. So how we can do this one? Nanoscience is trying to reduce this one and also trying to change the carbon emission also. Now, nanotechnology conversing water, understanding the role of nanoparticle in soils, water retention. This one. How we can control it is a very simple example. It is not in detail. Create ammonia needed in fertilizer. Create artificial iron in water. The process is already given by many researchers. Prevent erosion with soil binders that hold soils together. Clean soils using nanoparticles in water that clean the soil as they pass through it. Thus, the wastage problem is little bit decrease. In the near future, nanostructured catalysts will be available, which will increase the efficacy of the pesticide and herbicides. Although researchers are already doing, researchers are already working on this field, allowing lower dose to be used, and hence this field is also very much interesting. How to enhance the photosynthesis, improve germination, improve fishing practices, breeding and antibiotics, remove contamination from water. Now going to the market, nano food market is around about $2.6 billion in 2014 and it is increased 7.0 billion, means 3 times greater in 2016 by the 2 years and total $20 in $20.4 billion in by the 2020. 200 companies are currently engaged in the nanotechnology production, but only a handful of nano food products are market available now. I wonder what nano food will be on your plate first. Nanotechnology can provide foods that looks and taste better, are more nutritious and safer than what we eat today. Nanoscience is also working to educate the public, farmer, layman, develop regulations to manage and monitor nanotechnology development in food industry as well as in agriculture. Some social and ethical problems are also here, which can be sought out by the scientists. While these nanotechnology development in agriculture and food technology infringe on human rights? No. Could any of them decrease privacy of individual? Answer is no. Could the use of nanotechnology for agriculture have unwanted and negative environmental effects? No. What economic impact could the use of nanotechnology in agriculture industry? Might they be negative or positive? I think your answer is also positive. If so, are these developments more important than your privacy, your right as a citizen, your right as a human being? Or the answer somewhere in between? The agriculture website is already given here. If you are interested to see the agriculture website, the agriculture website are here. The Asian Food Regulation and Information Science and its website is also available here. Before giving the thanks, I will tell you the strength of my work, and my students are my strength, and their names are written in the right side of the slides. And thank you for hearing me. Thanks a lot. Any question? Yes. Any question? So again, I thankful to Department of Chemistry, APS University Satna, and the whole organizing team for giving me this opportunity. Thank you very much. Can you hear me?
Okay, thank you, ma'am. Thank you so much. Am I audible? Hello. Hello, am I audible?
Yes.
Hello, Pragya ma'am, are you there?
Hello, Pragya ma'am. Hello, Pragya ma'am. Hello. Hello. Pragya ma'am, proceed. Pragya ma'am, proceed.
Yes, yes, sir. Thank you, ma'am.
Okay, okay.
Thank you
Proceed.
for your good presentation. Very nice hearing you. Ma'am, please stop sharing. Just click on that stop sharing button. Archana ma'am, please stop
Yes,
sharing.
sure. Sure,
Yeah,
sure.
your
I
screen
will
is
try.
still. Yes, ma'am. Stop sharing. There is an. Hello. Your screen is still sharing, ma'am. Stop sharing. Ma'am, your screen is still visible.
हाँ सर बस ऑनलाइन हुई है कनेक्ट करिए
Yes.
कनेक्ट हुई है ना सर हाँ यस सर तुरंत डन
On RN Patel, sir.
यस सर ओके सर यस सर हाँ जस्ट
Ma'am, there is a button. There is button. Just open this Google Meet. Just open it. Google Meet. Open the Google Meet.
वो कल वाले
अच्छा वो कर रहे हैं
Yeah, here it is written. Stop sharing. In your second window, Meet. Yeah, stop presenting. Yes. Just
Misra
click over
ji,
it.
please
Thank you,
mute
ma'am.
your mic.
कंटिन्यू
Misra ji,
यहाँ से थोड़ा बहुत
Misra ji, please mute your mic.
Mr. Sir. Okay. Now, continuing to our series, our next presenter is Dr. Suren Prasad. Dr. Suren Prasad is working as a professor and a head of chemistry, School of Biological and Chemical Science, Faculty of Science, Technology and Environment, the University of South Pacific, Suva, Fiji. Dr. Prasad has more than 28 years of research experience along with 25 years of teaching experience. He supervised a number of postgraduate, graduate, PhD students for their research project. He organized and attended many conferences and published more than 65 research papers in professional journals. He completed many of research projects in collaboration with scientists, researchers of other countries of all over the world. His research areas specialization are analytical and inorganic chemistry, applications of chemical kinetics as an analytical environment tool, pollutant, toxicants, food chemistry, kinetics and mechanism of ligand substitution and oxidation reactions, microbial degradations of organic pollutants, synthesis, characterization, and biological studies of inorganic complex pyrolysis of hydrocarbons. He has more than 115 published papers in top international journals, 3 review articles, books and chapters, 6 journal publications of public interest, 9 journals and books edited, 7 course books written and revised, 37 invited keynote lectures in different countries, and 80 abstracts published in conferences and presentations. So, Dr. Suren Prasad, I welcome you on behalf of AKS University Computer Science Department. Hello. Hello. Dr. Prasad. Hello, Dr. Prasad. I am audible to you. Unmute yourself. Dr. Prasad. Just unmute Just unmute yourself, Dr. Prasad. Some technical issue. He'll be with us within a minute. Yes, sir. He's just unmute yourself, Dr. Prasad. Yourself. Click on it. Tap that. Tap that. Tap the unmute button. Unmute button. Tap the unmute button. Yes, sir. Hello. Yes, sir. No, no, no. No, he is not logged in. Exactly. He left the meeting. Exactly. Yeah.
Hello.
Hello,
Yes.
Salim, sir.
Let us
Who is going to be our next speaker? Just
let us wait 1 minute. I am talking with
yes.
Mishra ji.
Yes, sir.
Hello, Pragya ma'am.
Hello.
Hello, Pragya ma'am.
Hello,
Yes,
ma'am.
sir. Yes, sir. Yes, sir.
Yes, give the chance to next speaker.
Next
Puneet
speaker,
Pathak is
Professor.
ready. Puneet Pathak. Puneet Pathak is ready.
Is
Puneet Pathak.
not logged in, sir.
No, Puneet Pathak.
Hello?
Hello, Puneet Pathak. Hello.
Yes, yes, I'm
Yes,
here,
yes,
and I'm
ma'am.
ready.
He is with us. He is with us.
Yes, sir.
Please connect with Pathak. Please connect the Puneet Pathak.
Yes, sir. Hello.
हाँ.
Dr. Puneet Pathak, can you
Yes,
hear
ma'am,
me?
yes. May I share my presentation?
Yes, sir. You can share your presentation. Dr. Puneet Pathak, I welcome you on behalf of Chemistry Department, AKS University, Satna. You can share your screen. Yes, sir.
Is it visible?
Yes, sir. Now you can continue.
Thank you all of you, especially Dr. Samit Kumar for providing me to this conference and for giving me the opportunity to talk on the topic that is recent developments and current scenario of entire world energy use. In India, in most of the today's paper mill employs technology ranging from the oldest to the most modern, and that is mainly because they have been in the existence of for many years, and these mills use a large variety of the raw materials like wood, bamboo, recycled fiber, bagasse, and wheat straw. So the percentage saving of recycled fiber waste mill in India is highest, that is 58%, and which is followed by the 25% of the wood-based paper mills, and the last raw material is that the agro waste, which accounts for the 17%. And besides using 25% of the wood, pulp and paper industry manufacturers in India do not destroy the forest. In fact, this industry plant planted more trees than it has taken from the land. So as the GDP of any country is growing, the per capita consumption of the paper is also increasing. So among all the countries, we can see that the per capita consumption of India is very low. It is around 13 in the present year, and it is expected that it will be around 17 kg per capita till the year of 2024 or 25. So there are some facts of the Indian paper industry that India has around more than 1,000 mills. Among these 1,000 mills, around 750 mills of operationals, and we can see that in India the paper mill are highly fragmented, which can be seen by this graph, in which you can see that the top three paper mills of India shares only the 9% of the total production, while in the other countries the top three players contributes around 32, in USA, Indonesia it is 28, and in the China it is 21%. So the main reason may be because in India the paper mills are very fragmented, and there are more than 1,000 mills, and the estimated turnover of this industry is around 60,000 crore, and which provides the employment to millions of the people directly or indirectly. So as I have already said that paper industry is using the lignocellulosic raw materials like agro waste, wood, and recycled fiber, and all these raw materials contains uh, fibrous structures which is useful for the paper making, especially the cellulosic portion. So in a typical fiber, there are three main components, that is cellulose, lignin, and hemicellulose. As you all know that cellulose is a polymer of glucose units, and hemicellulose is a polymer of glucose, xylose, arabinose, and many more other C6 and C5 sugars. And lignin is undesirable during the paper making because it is a cementing material which binds the cellulosic fiber together with the cellulosic fiber. So during the process of paper making, the paper makers want to remove this lignin from the cellulose and hemicellulosic portions. So at high temperature and with the use of chemicals, this lignin is uh, being fermented by the use of sodium hydroxide, sodium sulfide, and all other pulping chemicals, and these chemicals dissolve the lignin, and after that the cellulosic fiber portion is used for the paper making. So this is, in this slide I want to share some basic steps, and that is first step is degree chip. In this, the log of the wood or agro residue are fragmented into chips or small portion. After that, there is a process of pulping. In the pulping process, lignin is removed. We can see that there is a generation of black liquor which contains simply lignin portion and the pulping chemicals in the black liquors. And after removing this black liquor, we obtain a brown colored pulp. And this brown colored pulp can be directly used for the use in the packaging industry. But for writing printing rates, if this brown color should be removed, means the residual lignin present in this pulp should be removed prior to paper making. So after that, there is a bleaching process. In the bleaching process, different types of the chemicals are being used in a sequence, based on their specific reactions and based on their specific reaction towards the lignin. So as the lignin is removed in the process, the pulp gets brighter and more brighter. And if brighter should be around 85 to 90% for a good paper. And after that, we found a bleached pulp. Uh, but this bleached pulp does not have any stern property if you use it as such, because there is a no bond formation between the fiber. So there is a process that is refining in which mechanical energy is given to the fiber so that the lumen of the fiber is flattened to give more surface area. And after that, there is some fibrillation on the fiber surface. You can see in this figure that there is a fibrillation on the fiber surface. This fibrillation generates hydroxyl group opening of the hydroxyl groups, which forms the hydrogen bonds with the adjacent fiber, and which provide the strength to the paper. And after that, there are some additives which are being used in the paper making for sizing, means to make the paper hydrophobic, fillers for filling the inorganic material, some adhesive dyes, and some retention aid. After that, it goes on the paper machine where where the water is filtered, and a web of the paper formed on the felt, and it is dried, then coated, and then calendared to make a smooth paper, which is generally being used by the paper consumers. So in this diagram, I want to just summarize that there are two types of the paper mill. One is integrated in mills, in this pulp mill and paper making. Both processes are going on in the same mill, but there are some mills which cannot produce the pulp, so they directly buy the pulp from the market and they prepare the paper from the that pulp. So there may be two type of the paper mill based on the facility of pulp mill and paper making sections. So now, what are the problems faced by the products and the products and processes due to the conventional process which is being applied in the Indian paper industry? First one is on the raw material. The main problem is based on the availability, cost, and its storage and preservation, because we cannot store the raw material for a long time due to microdegradation. Then pulp quality issues, because in this paper industry different type of chemicals are being used, so there are some quality related issue occur like brightness sealing and brightness reversion, loss of viscosity, and pulp drainage. These are some terms which are generally being used in the paper industry, and these quality issues arise during the paper making. Then material and resource utilization means high chemical consumption, high water consumption, because the paper makers are under pressure to minimize their energy consumption and chemical consumption. So this is the main problem: material and resources utilization. Then paper quality upgradation and chemical recovery are others problems related to the processes. So to overcome these problems, there may be some eco-friendly solutions which are by paper makers, paper industry nowadays. And in each and every process, biocatalysts that we all know as enzymes can be used. But some enzymes are at mill scale, some are at pilot scales, and some trials are at laboratory scales. So basically, these enzymes are proteins and certain class of the RNAs which catalyze process of the properties, power of specific activation, and these are specific towards a specific substrate. Means a specific enzyme will act on the specific substrate. It cannot act on the other substrate. And there are these enzymatic application needs mild conditions in the application processes. So these are the areas. I have put some major areas. There may be some other areas, but here I have given the names of those areas which are being applied in the paper industry at mill scale or at a pilot scale. So as we can see that enzymes have been applied in the bleaching area at mill scale, pilot scale, and laboratory scale. And in the refining area, it is at the mill scale. And in the sizing area, means for the reduction of viscosity for the starch, amylase are being used in many of the industries in India as well as in the whole world to reduce the viscosity of the starch. So in this slide, I just want to show a study carried by the Demner, which shows that more the enzymatic patent had been taken by one of the two enzyme industry, that is Novo Nordics and Novozymes. These are manufacturing industry which have paid out pulp and industry. And there is only one paper mill from the Japan, that is Ozi Paper, which have taken around 19 patents on the pulp and paper processes. So means paper industry nowadays are going to use the enzymes in their processes, and most of the enzyme manufacturing industries are also producing enzymes, especially for the paper industry. The total consumption of enzyme for pulp and paper industry is 2% against the detergent industry, that is 30%, and starch, that is 12%, baking for 8%, and textile 11%. It is quite low, but now people are using these enzymes in the paper industry. So what are the main enzymes? On the bottom of this slide, you can show that cellulase, xylanase, lactase. These three enzymes are mainly used for the paper industry, and the uses of these enzymes can be seen in this slide. That bleaching boosting efficiency of enzymes is the major area where enzyme has been applied. There are some other areas that increase in thermostability, delignification improvement, fiber modification. All these areas are also touched by the enzymes for the paper industry. So as I have already said that these enzymes are specific to specific substrate, and so based on those specificity, cellulase can act only on the cellulose, and it will partially hydrolyze during the fiber modification process in the refining process to increase the strength of the property. So in this slide, I want to show where enzyme can be used, what there is application, and what is their function in the industry. So during recycling process, these cellulases can be used for the removing the ink from the fiber surface in the inking process. And for the drainage improvement, these cellulase act on the fine content to improve the drainage of the water. So if drainage is good, then machine maintainability will be good and paper production will be enhanced. Then xylanase act on the xylem. So it is used generally in the bleach boosting for the dinking, for the bleaching purposes. Then manganese act on the glucomannan, and it removes the glucomannan, and it also acts as a bleach boosting enzyme. So all these enzymes save the bleaching chemicals, means they are responsible to minimize the chemical consumption which are being used in the bleaching, that is chlorine, chlorine dioxide. These generate some organochlorine and furans type toxic chemicals, which can be reduced by the use of enzymes prior to bleaching portion. So then lactase act on the lignin, again for the bleaching, manganese peroxidase for lignin, lipase act on the fat or oil that is used in the printing process, means some means contains oil as a carrier. So during deinking, these lipase enzymes can act on the oil, so the lipase degrade the oil portion, and that's why they assist in the ink removal. Amylase enzyme acts on the starch. So during the coating, starch viscosity should be low. So in place of using chemicals, industry are being used amylase for starch modification. Then protease act on the proteins. So this enzyme can be helpful for the biofilm removal, but it is on the pilot scale trial now. Pectinase act on the pectin, and it hydrolyzes the cambial layer. So during the debarking stage, these pectinases can be useful to minimize the energy to minimize the energy consumption. So now I want to show some details around about the biopulping. So biopulping is the process in which fibers are removed from the uh, wood chips to make the pulp fiber. So in this, wood is debarked, then chipped, and then screened, and then is a pile is formed. It is sterilized, and fungal inoculum means some white or fungi are inoculated in these piles, and it is highly ventilated. After 1 to 4 weeks, these white rot fungi will grow, and they will degrade the lignin. So if lignin is already degraded prior to pulping, so less amount of the energy and less amount of the chemicals are required during the pulping process. So there will be the reduction in the pulping chemicals. So the selective degradation and the modification of the native lignin which is present in the wood chips are mainly degraded by these white rot fungi. And the most utilized bioprocess by using endemic biobleaching, and that is a process which removes the lignin from the chemical pulps. So as you can see that this is the pulp which is obtained after the pulping process, but after the use of several chemicals, the brightness of this pulp is increasing, means it becomes more brighter. So enzymes can be used after prior to any bleaching sequence. So these enzymes can be hemicellulase and linolytic enzymes. So these gyrase enzymes mainly attacks on the hemicellulase, and it alters the interface between the cellulose and lignins. Means it breaks the bond between the lignin and cellulose. So if the bond is already weak, then when we apply the pulping chemicals, then those pulping chemicals, those bleaching chemicals will be easy to get into the lignin portion, and it will be more effective in the presence of enzymes. So as you can see that when enzyme is added, the hemicellulosic portions are degraded, and it is easy to remove the lignin from the cellulosic fiber. And it also acts to hinder the redeposition of these hemicellulose on the fiber surface, because they protect the cellulosic fiber for the penetration of the bleaching chemicals. So more chemicals is required if enzymes are not used. In the presence of enzymes, these hemicellulosic layers is dissolved, and the chemicals which is used for the bleaching can be easily penetrated to the lignin portion of the fiber. So then other enzymes are lignolytic enzymes which directly acts on the lignins. And these enzymes are mainly the lignin peroxidase, manganese peroxidase, and lactases. But these enzymes are under the trial at pilot scales uh, due to the short half-life period of these enzymes. So these enzymes are not currently being used at a mill scale. Now, third application is on the biorefining. So in this slide, we can see that there is a fiber and there are several layers like primary layer P1, then secondary layer. Secondary layer is again divided into S1, S2, and S3 layer. So for the paper making process, if bonding is required, then this S2 layer is responsible for the bonding. So we have to remove this S1 and P layer before paper making. So by mechanical action, that is refining in the PFI mill or validator, this S2 layer is exposed and the lumen is flattened and some fibrillation occurs. All these helps to make the paper stronger due to the bonding between the adjacent fibers by intra and inter hydrogen bonding. So cellulose and hemicellulose helps to remove this S1 and P layer because it is cellulose and hemicellulose. So cellulose and hemicellulose can act on this layer. So energy requirement in the successive treatment will be lower if enzymes are used in combination with the mechanical treatment. Now for the recycled fiber, enzymatic dinking is being used. As you can see that this is the waste paper, and if we form any paper from this paper without removing the ink from the fiber, then the whole pulp sheet will be black. So you cannot write anything on this paper. So prior to using it for writing and printing paper, we have to remove this ink. So in conventional inking, sodium hydroxide, sodium silicate, um, and some bleaching chemicals are being used. So there are some waste paper which cannot be dinked by this chemical dinking. It's like photocopier paper or laser printed paper, which are generally being used in our offices in huge quantity. So these paper cannot be recycled back into the writing and printing paper. These are dumped. So for those hard to dink toner ink, uh, enzymes are required. So in this, if enzymes which are reacting with the fiber, they are mainly cellulase, hemicellulase, pectinase, and lignolytic enzymes. But there are some enzymes which act directly on the ink, on their carrier molecule, that may be the oil based. On that cases, lipases can be act, and there are some ink like toner have some polymeric component. So on those ink, esterase may be act. So these enzyme attacks on ink itself and fiber cells, and it weakens the in fiber and ink particle bond and thus remove the fiber and fines. So in this slide, there is animation. This is the fiber surface on which ink particle are attached. So it is entrapped on the cellulosic fiber. So when we use enzymes, the symbolic enzyme, they act on the cellulosic fibers and remove the microfibrils from the fiber surface along with the ink particle. On the other side, they also fibrillate the fiber surface so that the strength of paper is not going down. And during the washing and flotation process, this ink is removed. Now, last application is stickies control. And in the recycled paper-based mills, they are facing the problem of stickies. Stickies are the material which have tackiness and hydrophobic property. And these sticky materials may come from the ink particle from the gum, which is generally applied on the papers. So these sticky materials, when it comes in contact with the draft section at higher temperature, they melt on the paper machine. So there are some deposits on the paper machine and dryer section. So it can be removed by the use of esterase enzyme because these esterase enzyme can break the ester bond in the polymers, and thus the runnability of paper machine is improved because less cleanliness is required if enzymes are being used. Now, what are the limitations? Because paper industry are using different type of enzyme in the acidic range, in the alkaline range, in the normal temperature range, higher temperature range. So enzymes are working in the mild conditions. So the main limitation is that these enzymes is working in the mild conditions, so it should be effective and stable over wide range of the pH and temperature, and it should be compatible with the technology of the pulp mill, because no pulp paper or pulp industry wants to deviate from their conventional process. So your enzymes should be retrofit in the existing processes. So and bio bleaching, gallonase and lignotinidine are used, but there is a possibility that during the production, the cellulase enzyme may be present in that enzyme as a contaminant. So that cellulase enzyme can harm the cellulosic fiber. So it should be free of cellulase enzyme. So these are some advantages that for the enzymes, low temperature and low energy are required, less byproducts are generated, and if these enzymes are immobilized, then it can be reused. In some mills, it is used, and 2 or 3 times it was recycled for the any purpose. And these enzymes are biological molecules, so these can be degraded biologically, and these are some disadvantages that they are unstable at extreme temperature, they are unstable at extreme pH, and they are in current scenario some enzymes are expensive, like lignin peroxidase, manganese peroxidase. These enzymes are expensive, so they are not being used in the paper industry. So there is a need of third generation enzymes that non-cellulitic preparations have been produced by genetic enzymes in the lab, and by selective inactivation of the cellulase producing enzyme. And now that the researchers are focusing on the discovering of thermostable alkaline active enzymes and high turnover numbers. Already some enzymes are being used, like amylase enzymes, uh, which is used in the surface sizing for the reduction of viscosity, and that can act at the temperature of 90 degrees Celsius. So people are working on this aspect. So in the last slide, I want to say that industry is sustainable when it produces goods and services in such a manner as to meet the needs and aspirations of the present without compromising the ability of future generation to meet their own needs. But on the other hand, some balance is also required. Means excellent environmental performance is meaningless if no wealth is created for the paper industry. So they are thinking that manner, that wealth in a destroyed environment is equally senseless, no matter how wealthy society fundamentally looking in social equity cannot be sustained. So thank you, all of you.
Question. Hello.
Hello.
Here the question.
Yes, sir.
Thank you, Pathakji, for your good presentation. My very simple and general question is, we always talk about the traditional paper technology in the country.
Yes,
I mean, in our country, India.
yes,
Now, looking to the vulnerability of climate change, our forest and the existence of forest is very crucial and necessary, as they serve as a great carbon sink.
yes,
India, as you know, has vast amount of agriculture and horticulture waste. I think
yes,
millions of tons of agriculture and horticulture waste is generated every year
yes,
with
yes,
different fibers, as you talked about, lignin, cellulose, hemicellulose, etc., etc.
yes,
Do we look for any enzyme to act for these fibers I'm talking about in agriculture and horticulture forest? And also, do we think on the lines of producing paper out of these fibers uh, and save our precious forest for papers? Because the primary requirement these days is to minimize the energy requirement during paper technology, the water requirement and the chemical requirement, and it should be eco-friendly practice, which
yes,
is
yes,
in India not. I have observed that most of the paper factories or the paper, mills in the country,
yes,
I
yes,
don't want to mention the name here, but they pollute all the water bodies, nearby water bodies, the land and the air around.
Yes.
So let us go for some alternatives to get rid of the traditional paper technology and come up with the eco-friendly technology. Your view, please.
Yes, yes. So first, I want to clear that no paper industry is using wood from the forest, because what paper industry are using, they that are based on the agroforestry, that is
Okay.
eucalyptus or poplar, and due to the restriction from the forestry, no one can harvest any wood from the forest. So in our country around, I have seen our first slide that I have mentioned this line that first pulp and paper industry is not using any wood from the forest. So that portion is around 25%, and you can see there 17% is agro residue. So paper mill is already using the agro residue, but the agro residue which are being used, that is mainly the wheat straw, bagasse, and in some cases that is rice straw. But there are some limitations with the using agro residue, because agro residue contains silica in high amount. As you know that it can be 10 to 15% in the raw material, so that hinders the chemical recovery processes. So any raw material, any agro residue which have high silica content cannot be used as a raw material for the paper making. It can be used, but the effluent generated after the pulping cannot be used for the chemical recovery. So those industry who are using rice straw as a agro as a raw material, they are dumping their water in the river bodies. So paper industry is, I think, using agro residue from several years. And on the other hand, you can see that paper industry also using recycled fibers. So now in India, this portion is increasing. So 5 years back, it is around 35. Now it is around 60%. In the near future, it will increase both recycled and agro waste.
Okay, Pathak ji. Okay. Thank you.
Okay. Thank you. I will stop my presentation.
Thank you, Dr. Puneet. Thank you so
Dr.
much.
Khalil. Thank you.
Hello. Thank you, Dr. Puneet. It was very
Okay.
nice presentation.
Thank you, ma'am.
Thank you, sir. Now I request Dr. Suren Prasad. Dr. Suren Prasad? Yeah. Okay, okay. Okay. Dr. Chitsen Gupta. Hello, Dr. Chitsen Gupta, can you hear me?
Yes, yes, I am hearing you. You can also hear me.
Yes, sir. Yes, sir. Yes, you can share your.
Hello,
You,
Pragya
you
ma'am.
can.
Hello.
Yes, sir.
Actually, Dr. Prasad is there, and he is ready.
Oh,
Okay.
Suren Prasad.
Yeah, yeah.
So, yes, sir. So, may I continue with Dr. Suren Prasad?
Yeah, 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 ma'am.
Dr. Suren Prasad, can you hear me? Dr. Suren Prasad, can you hear me? Dr. Suren Prasad? I think he is not connected yet.
Yes,
Ma'am, just
proceed, proceed.
wait just a minute, ma'am.
Yes, sir.
Wait just a minute.
Yes, ma'am. Yes, sir. Yes, sir. Can you hear me? Just yourself. Yes. 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 Now speak something so that I can test. Hello. Dr. Suren, can you hear me? Dr. Suren Prasad, can you hear me?
कि हमारे जो इन्वाइटेड हैं उनको बोलने नहीं दे रहे। एक बार मैंने कर दिया, बात हो गई, दोबारा से कुछ मत करना, दोबारा मेरी आवाज आपको आ रही है क्या?
Dr. Shalin Yadav, please mute yourself. We can hear you all. Dr. Suren Prasad, can you hear me? Dr. Suren Prasad, can you hear me? You have muted unmuted yourself. You have to open the that click on that video button also, so that we can see you. Hello, Dr. Suren Prasad, please unmute yourself. Unmute yourself. Yes, already something so that we can listen. Hello, not audible. All audible. We cannot listen you. Hello, Dr. Suret Prasad. Can you hear me? You have to unmute yourself. There is an unmute button. Just tap on that. Tap on that unmute button. Hello, Dr. Suren Prasad. Yes, sir. Hello, yes, sir. Yes, sir. Yeah, yes, sir. Last chance, one last time I should try. Dr. Suren Prasad, just unmute that button. Unmute. Mic button, mic button. Tap on that. Tap on that. And there is one more button of a camera button just beside it. Just tap on that. Hello? Okay, sir. We will continue with our next speaker. Now we will continue with our next speaker, Dr. Dr. Chit Sen Gupta is an associate professor at KPG, Jaunpur University, UP. He has researched many research papers, both national and international. So, Dr. Chit Sen Gupta, welcome, sir, from on behalf of AKS University Chemistry Department. Now, the floor is yours, sir.
Thanks, madam. Good afternoon to all of you. Myself, Dr. Sudarshan Gupta, and I am here. Am I audible to all of you?
Yes, sir, your presentation is visible. Minimize. Yes, sir. Minimize this window. Yes, minimize and maximize this presentation.
Okay.
Okay, yes, it's visible.
I am going to start my presentation.
Yes, sir.
This is myself, Students.These Gupta. I am Associate Professor in Department of Chemistry, Koti Postgraduate College, Chakke. And this is my college. And this is the topic for today's presentation. Teaching aids for e-education of first of all I would like to cite here that my presentation is for those teachers who are still addicted to traditional chalk duster methods, and this period, which is highly disturbed with corona threats, classroom teachers are highly paralyzed with such kind disturbance are using their teaching. So, going to start my topic now. This is science, especially chemistry. Traditional chalk duster method sometimes seems like to us a blind to see a mute film means if we ask some mute blind person to see a movie, good movie, but he can't see such movie, and such like to ask a dumb to hear a sweet song, same manner to ask a mute to tell his problems, whatever he faces, he will be to tell whatever problem he has because he has mute. So why this kind of problem we are facing in our classroom? This is because of three-dimensional presentation and stereochemical aspects of giants and complex molecule, time consumption, drawing complex structure, complete equation, radius calculation, and so many other various problems we are facing in that type of classroom, and so on. Beside these problems, we are facing several other problems like number of students, disturbance made by students, and so on. So I'm not going to discuss that kind of problem here. So this, when we are concerning our subject, this is chemistry. Chemistry not only single subject. This is the branches of combined of some several branches like physical chemistry, inorganic chemistry, organic chemistry, and so many other branches like biochemistry, biological chemistry, or statistical chemistry, mathematical chemistry, so many branches. This is very broad, versatile subject. So you can see this is chemistry, several branches and lots of difficulties, equations, radius equations, stereochemical aspects, stoichiometric aspects, and so many aspects. This aspect I'm not going to discuss here. So at present, everyone knows the threats of COVID-19. This threat is highly damaging our traditional educational system, which is mainly based on chalk duster method, which is mainly occurs in our class educational institution in classrooms with the students outside teaching, and due to this corona threats, we are facing lots of difficulty because so many time is wasted with such kind of difficulty. So due to this, you can see the coronavirus. This coronavirus is highly infectious, so we can't run our classrooms due to such kind of threats. So now I'm going to start my lecture. I'm discussing here two teachers, Mr. A and B. Suppose Mr. A, his academic record is more about 80% toward his academic career, and Mr. B, who got 55% to 60% throughout his academic career. But teaching efficiency, when you're concerning about teaching efficiency of Mr. A, this is about 20%, 24%, and Mr. B has teaching efficiency of 80%. Here, teaching efficiency means whatever percentage of knowledge what Mr. A can provide to his students, and Mr. B what kind of knowledge or what amount of knowledge Mr. B can provide to his students. So if we concerning about this data, what we get about 16%, 16% data, only 60% data Mr. A is able to deliver towards students, whereas Mr. B is able to deliver about 44% data to his students. So when we concerning quality of teacher, so who will be a good teacher? Mr. A on behalf of his academic record, or Mr. B on behalf of his academic ability or teaching ability. So this is not matter of discussion. Matter of discussion is that how a Mr. A type teachers, how Mr. A type teacher will improve their teaching skills, their teaching efficiency before his students, so that can he deliver more knowledge to his students and deliver his lectures more efficiently. So what kind of step Mr. A should taken? I am going to discuss such steps in my presentation. Okay. So Mr. A will opt for some teaching aids like computerized teaching aids, which is very necessary in this kind of circumstances where we are all are facing corona threats. So for sake of presentation, I just divided these kinds of aids into two categories. There will be so many categories. The particular simplicity this is offline teaching aids and online teaching aids. So first of all, we can go over offline teaching aids, which is just like this. First of all, what we can do to modify to improve our teaching skills. This is multimedia slide presentation. This is just like this. I am going to take just example. This is another slide prepared by me, and I just taking it as example for the PowerPoint presentation. So just everyone is here is understand what what is PowerPoint. So I am not concentrating over here. I am going to just next topic, animated graphics and movies, which is more related to here. Suppose being a chemistry teacher, I have to teach structure of methane. So when we concerning the bond angle of methane, we find this is 109 degree to 8 minutes here, and when we going to draw the structure of methane on blackboard, generally we made the structure of methane like this. So here we are citing here the bond angle of methane is 109 degree to 8 minutes, but you can see there is no 109 degree to 8 minutes. It seems about 90 degree. So students will face more difficulty to understand it. Now another way to draw the structure of methane in two-dimensional blackboard, this is just like this. Here one angle seems like 120 degree and another one angle seems like 60 degree. So what is to eliminate problem? We just go for animated graphics and movies. This is just like this. This is structure of methane, what I prepared with the help of some software. I am discussing here. This is structure of methane. Any student can understand easily the bond angle of CH bond between is very well visible to all students, all of you, that bond angle is about 109 degree. This is quite more than 90 degree and quite less than 120 degree. Okay. These are several structures of methane, which is very well citing bond of methane. Another example what I have, this is 3D image of cyclohexane. Cyclohexane, when we draw this structure of cyclohexane, generally it seems planar. All carbons of that ring in same plane, and students may face some difficulty to imagine the structure of cyclohexane. So with this help, we can cite the structure of cyclohexane very easily. Any student can understand the structure of cyclohexane. All 6 carbons are not in same plane. 3 of carbons in same plane and another 3 of carbon in another plane. So this is the structure of cyclohexane. Now I am just going to next step. This is software based presentations. With the help of some educational software, how we can improve our teaching efficiency, teaching skills before our students. Some freewares what I choose from the market and some I have. This is one of this software is IR Tutor. With the help of this software, I am sure that any teacher can. This is created by some group of scientists, and I would like to thank those scientists and just acknowledgement point of view. I am citing their names here. So this is one software through which anyone can teach all the lectures of IR spectroscopy without speaking a single word. It is very, very easy sort of, but for example, you can see this is the molecule of 2 atoms, diatomic molecule. You can see the stretching of one and vibrational spectra of such kind of molecules. So, and stretching and bending exhibit several kinds of bond present in organic molecule. So this is just information purposes. I am leaving now. Second software is periodic table. The developer is Krishna.R. This is freeware. You can select it from choose it from website Krishna.R. This is very useful software for teachers who are teaching inorganic chemistry. With the help of this single software, you can teach each periodic properties. Here, all the periodic properties given in single chart. Suppose we have to discuss property of cobalt, so there are all properties of cobalt cited here. Some reactions. Here I am discussing it is also very good. And some very lot of information regarding predictive. Teach in organic chemistry very efficiently. You can use this kind of software. So another one software is the graphical tablet, drawing tablet pen. This is graphical tablet, drawing tablet, a pen tablet. This is a device through which you can cast your screen from smaller screen to bigger screen, as well as you can write freehand write as you write on blackboard in comparison to write at a small copying pad. You can see this is a simple smiling line.
वेलकम टू माय चैनल। आज का वीडियो इन सभी टीचर्स के लिए है जो कि ऑनलाइन क्लासेस ले रहे हैं। इफ यू आर न्यू टू दिस चैनल, आई सजेस्ट
You can see with the help of this, you can write freehand. With freehand, as you write at blackboard. So if you feel difficulty, write on blackboard. You can use this small platform for writing, and you can make it display on big board. So with the help of this software, you make big screen into small screen. So next is type is this is casting or screen casting. Screen casting is some with the help of some devices like Anycast, Miracast, Chromecast. These are some devices which are useful to cast whole the screen from one screen to bigger screen. You can see this is mobile handphone, this is desktop, palm top, and this is laptop, and you can make this display to big screen so that it can be very easily visible to students. See screen. This is casting over big screen. And it will be very well spread in small size. So another type of is podcasting used. So such kind of devices useful to provide audio transfer protocol to students. This is from place to another place with the help of either Wi-Fi or Bluetooth or so many other devices. This is the source of the software. You can go and check the software how that can be helpful for our teachers. So our next technique is software-based calculation. How this technique can be useful for teachers. Suppose I have some software, educational software, and I will going to use such software in teaching our students. Suppose we have to teach nomenclature. So I just have freeware version of ACD Chemistcase. This is very well-known software. You can find it on acdlab.com. Suppose I just draw one structure of a simple molecule, and I have to find the name of this molecule. So with the help of this software, you can very easily get the name of molecule. This is butane 12. So you can use this software for finding the Casey name of some smaller size of molecule. If you like this software, you can purchase it full version and the professional version. That will be very useful for all the teachers. Next, this is the structure and properties of molecule. Suppose you have to find some data of properties of some structure, some molecule. So again, I am using this software. I have several other software, but for sake of simplicity, I just taken this software, and I just draw the structure of some, and I am going to find calculate these are some molecular formula weight, composition, refractivity, and so many properties which are very easy to find with the help of this is free. It's concerning website. So now I am going to next. This is simple software converter. Suppose you have to convert one unit to another unit. This is several other types of conversion. Force. There are several units of force. There are also several units of force. You can easily convert any amount. Suppose we have to convert 100 dyne into force. So it is about to output is itna. Okay, output is about this much amount of kilogram force. So this is the use of this software. Now, fourth type of offline teaching aids is instrument-based computer programs. Instrument-based computer programs are generally those programs like HPLC, GCMS, NMR, IR. With the help of this kind of program, we can find data associated with such instruments, and with the help of such data, we can elevate our teaching resources. So these are several offline teaching aids. Now I am going to discuss online teaching aids. Online teaching aids, there are several types. For sake of simplicity, I just divided into several categories. This is one category, use of search engines. Use of search engines, these are some sites which directly search topic related to your teaching. Suppose I am just searching YouTube. So you can find several structures, some such I am just trying studio chemistry. Studio chemistry, you can find so many videos related to studio chemistry, and you can very easily learn if you have any difficulty in subtopic. There are so many subject experts in this site. So with the help of these sites, you can use this site for your teaching purposes. Now, use of educational website. Educational website. There are some educational websites. There are so many websites, millions of websites, which are able to provide educational support to such teachers. I, for sake of simplicity, I am just taking website. This came q3d.com. It's a very useful website for providing animated reactions. For example, I am taking this elimination. This website, through this website, you can get so many structures, very animated ones, and I think internet speed is slow, so this is not able to visualize such reactions. Anyway, you can use reaction. Suppose we click on this arrow, then there is one cleavage of this molecule visible, and again clicking and this arrow, that will be show whole sun. Okay. So this is one kind of example. There are so many other sites. You can use so many sites. Now, use a virtual classes, which I find a study lecture. I just made a screenshot of a study lecture of some person. There are several platforms you can use your class, your meet, and so many platforms which are providing. These ones are very useful and very good to compare to normal traditional classrooms because the, because of their no limitation of space, no need of physical attendance, no management of students, and some other extracurricular activities of teachers. Suppose I am associated with NCC related responsibilities in my institution, so I am not able to provide so many times to my students. I am just using such kind of platform to my students so that I can provide a lot of time to students also in online classes. Use of e-resources. These are several kinds of electronic resources through which we find freewares, educational matters are freewares. This is free to site. You can find free PDF matters for your educational needs. Uh, this is again this loop. I think it will take time. I don't have so much time. Just if these are some educational sites. In here, this site with the help of this site, you can find educational resource. This is also for educational resource. This is for animated reaction, what I discussed earlier. Especially, this is a site for especially science and mathematical subject, mathematics videos. You can get 3 videos of science and associated with mathematics, and with the help of this site, you can organize animated videos of your classroom, whatever you are taking for your students. There are some restrictions. Some of matter educational resources are not free, and if you use such resources, you have to cite the authors or creators, whatever associated with such kind of resources. Now, use of communication devices. Communication devices, generally these devices are our cellular phones. CG nowadays, CG devices through which you can facilitate your teaching. Now, for example, this is screenshot of my mobile handset. I have several educational software in my mobile handset. For example, this is all softwares are generally freewares, and some of them are paid version and professional version. But I purchased and to using iPhone is Congress. So for these softwares are very useful in teaching aspects. So for demonstration of these softwares, I am going to join again with my mobile handset. So now I'm joining with my mobile handset. I can express this screen. I am leaving this screen, desktop screen, and I am joining again joining. Let's see that. Stop sharing. I am again going to join with my mobile screen. Am I visible to all of you? Hello. Am I visible to all of you?
Yes, sir. Yes, sir.
Okay.
You are visible.
Okay.
Yes, sir. You are visible.
Hello, thank you, sir. It was very nice presentation. Very good chemistry since I am a computer science as well as chemistry faculty. That I know very well that what thing you are teaching. Now, thank you. Now coming to our next speaker, Dr. Chitrahansh, please stop sharing your screen.
प्रज्ञा, हेलो
Yes,
प्रज्ञा
sir.
जी, प्रज्ञा
Yes,
प्रोसीड
sir.
करने दीजिए सर, प्रोसीड करने दीजिए, प्रोसीड कर लेने दीजिए, फिर आगे को प्रोसीड करने दीजिए.
Here I am sharing my screen.
Okay,
Yes,
okay.
These are some educational software. You can use this software through your mobile handset, and these softwares are some like I don't have too much time to press all software to cite all software in this, but these are chemistry healthcare, Kindra, and so many. One useful software I am going to share is chemistry by design. Those who are belong to organic chemistry field, this is very useful. You can find several step synthesis of long molecule, multi-step synthesis. You can see with the help of this software, you can find so many molecules, synthetic route of so many molecules. Several other software which are very helpful. This is one software which I am going to discuss here. This is 3D Sim app. Through this software, you can very well explain symmetry of some molecules, group theory of some molecules, and if you connect this mobile screen of mobile handset to big screen by casting screen or casting devices, so you can display this screen to big screen, and with the help of this you can see this is very easy to explain the structure of some molecule with the help of this software. And some of softwares so this is very useful software. This is molecular 3D. With the help of this software, you can explain some structure of. You can see the structure of anthracene. You can enlarge the structure in smaller form. So many other software. Too much time to discuss each of everyone. So I'm just leaving this side, and again I am and sharing.
Sir, we are running out of time, sir.
Okay, okay, madam. I am leaving now.
Yes, sir. Yes, sir.
Okay. Thanks to all of you.
Thank you, sir. Thank you, sir.
Okay, thanks, madam.
Sir, just mute yourself. Before in Seedhi, MP, India. He completed his graduation in 1983 and post-graduation in chemistry in 1985 from APS University, Riva. In 1991, he received his PhD degree in chemistry at APS University, Riva. He did DSc work at the Department of the Chemistry, APS University, Riva in 2009. Currently, he is a professor and head of Department of Chemistry in APS University, Riva. His research has been mainly focused on synthesis and characterization of transition metal complex as antioxidant agents. At present, his main research interests include design, synthesis, and biological evaluation of copper to nickel to vanadium 4th and 5th complexes as potent antioxidant agents, anti-diabetic, and anti-cancer drugs. He published more than 135 research articles in national and international chemistry journals. His collaborative work is in progress from Laboratorio di Studios Cristallographios IACT, CSIC, Universidad de Granada, de las Palmeras, Aramila, Granda, Spain, Department de Química Inorgánica, Universidad Madrid, Spain, Department of Chemistry, Faculty of Science, the MS University of Baroda, India, and Department of Inorganic and Structural Chemistry, Harvard University, Washington, D.C. He attended and delivered lectures in 9 international conferences. Professor Patel is also recipient of 3 awards in chemistry. So welcome Professor Patel from AKS University on behalf of AKS University Chemistry Department. Hello. Unmute yourself, sir. Sir, please unmute yourself. You are not audible. Sir, you are not at all audible. Just first unmute yourself. No, no, no. It's already muted. Just unmute yourself. Click on unmute button, mic button. Unmute yourself and click on that video icon as well. Dr. Patel. Unmute yourself, Dr. Patel, and click on that icon. Camera icon is there. You have to click on that. And beside that camera icon, there is a mic icon also.
Okay.
Hello? Hello?
Hello.
Yes, sir. Yes. Yes, you are now visible as well as, yes, audible also. Now, please share your screen.
Okay. Okay, ma'am. I am going to start my lecture.
Yeah.
The topic of my lecture is importance of hydrogens and their complexes. I have already given Mr. and I will I think he will
Yeah, yeah,
show,
sure, sir.
and then I will explain this. Before I thanks to our international 2 days international conference, patron of this conference, faculty member of EKS University Reva, and all delegates were associated with council. Now, my topic is the importance of hydrogens and
Your
their
PPT is now
complexes.
visible, sir.
Okay. Okay. Now, next, please. Next. Okay. The hydrogens are the versatile ligand and are considered as azomethane compounds. And all of you know the azomethane compound means those compounds which have the carbon, when nitrogen is connected by a carbon by a double bond, then it becomes a example of the azomethyl compound. I will show you the some example of the azomethyl compound along with their characteristic features which are already designed in my lab. So then hydrogens are usually named after their carbonyl compounds from which they are derived. Then hydrogens in general are prepared by monocondensing of the hydrogen aldehyde or ketones, or we can say these after monocondensing they release the water molecule and resin compound, yellow color, light yellow color compound which is obtained. In general, yellow color compound which is obtained is known as the hydrogens. Next please. Next please. Okay. The hydrogen ligands are the classified according to the number of the hydrogenic groups into the monohydrogens, which are characterized by the presence of one hydrogenic group. Let us see about their which are characterized by dihydrogen, trihydrogen, and there are their structural features. The main importance of these hydrogen ligands. These biological chemistry of the hydrogen may be attributed to the formation of the stable formation of the stable chelates with the transition metals present in the cells, and thus many vital enzymatic reactions cannot take place in the presence of the hydrogens. Hydrogen ligands and their complexes have wide applications, like these metal chelates are used in various applications. These are used like as anti-tumor drugs, as anti-cancer drugs, or anti-neoplastic, anti-proliferative agents, because the various additional therefore these hydrogen cells are act as an antimicrobial agents also against gram-negative, gram-positive bacteria, even for fungi and yeast. Some hydrogen to inhibit the growth of the chloroquine resistant strains of the Plasmodium falciparum. Next page. Next page. So Hydrogens and their complexes showed an activity as anti-inflammatory and anti-analgesic activities also. Hydrogen is in treatment of the overload disease. Means how the iron, if it exceeded in the human body or living systems, then it can be removed from the body after the chelation therapy, because these hydrogens are very good chelators of particularly the for iron 2 or iron 3 ions, and therefore it's a very good medicinal application is in treatment of the iron overload disease. Then coordination chemistry of hydrogens has been a subject of the competitive research since they exhibit a wide range of the catalytic activities in some polymerization as well as some oxidation processes. In the field of analytical chemistry, hydrogens were used in detection and determination and isolation of the compound containing the carbonyl groups, like when they have the aldehydic or ketonic groups, then they becomes very good tools in analytical chemistry for determination and isolation of the compounds. Some hydrogens are considered as analytical reagents used in spectrophotometric determination of the some organic constraints in pharmaceutical formulations, such as spectrophotometric determination of acetaminophen, phenobarbital, etc. Now, let us talk about some hydrogen compound which are designed to have some specific feature in our own labs, because this my topic is it's a pure educational topics, not applied one. So I'd like to tell the delegates and our viewers of these lectures how these hydrogen ligands are designed and how these are characterized by using the various physiochemical techniques. Like after designing, after synthesizing, first of all, we go for microanalysis and famous spectroscopy. After microanalysis, one can get the percentage of carbon, nitrogen, and hydrogen. And after using the famous spectroscopy, one can get the real molecular mass of these hydrogens. Then, for assigning the particular group, whether these hydrogens have what type of the groups are attached in them, they are characterized by using the electronic as well as IR spectroscopy. Then one can characterize if these hydrogen metal chelates of hydrogens are paramagnetic in features, then having this special property of paramagnetic of these metal chelates, one can very well study these hydrogens using the electron paramagnetic spectroscopy. Then redox properties of these metal chelates can very well be studied after using the cyclic voltammetry and differential pulse voltammetry. After using cyclic voltammetry, one can get the reduction as well as oxidation potentials. After getting reduction and oxidation potential, one can have the real redox or electrochemical feature one can be elucidated of such type of the synthesized or newly designed these complexes. And in the same way, one can have one can use the differential pulse voltammetry, because sometimes differential pulse voltammetry is much more useful than the cyclic voltammetry, particularly when the hydrogens gives the two reduction wave, and if these reduction waves remains very close to each other, then for identifying these two reduction potentials, then it becomes very useful to use another technique, and this technique is which is used in electrochemistry is the differential pulse voltammetry. So after using differential pulse voltammetry, one can identify these reduction potential which remains in a very close window, and one can have the then let us see the synthesis of a few hydrogens. The complexes these can be hydrogens can be prepared as I told you by taking the carbonyl compounds and then hydrogens, and one can prepare these ligands. After preparing these hydrogens and characterizing by using the various physiochemical techniques, then one can use this organic compound for preparing the metal chelates. And these metal the geometry of these metal chelates varies, and it depends on the chelation sites of these hydrogens, because these hydrogens are very good chelators and they can trap the metal ions, particularly transition metal ions. As I am using the copper ions, nickel ions, and particularly vanadium ions to see their medicinal values of these metal chelates. So I will tell you the synthesis of few example of the copper chelates which are prepared after using these hydrogen ligands. So let us take example synthesis of a metal chelates of copper. Please next. Please next. Next one. You saw the okay. Next again. Next. Next. Okay. You see here in this slide you see there is synthesis of the metal chelates are given after using the hydrogens. So here two metal chelates are formed after using these hydrogens, and you see here in this metal chelates copper ion is attached by 2 moles of hydrogens, and here the geometry of the copper metal ion is square pyramidal because 5 coordination site is covered by these metal ions. And as you see here in the same molecules there are 2 paramagnetic centers. Then you can say it's a example of the binuclear metal chelates, and each metal chelate each metal center which is paramagnetic in nature is bridged by a acetate ions because it is prepared by taking a copper acetate. Similarly, one can prepare bridged copper complex by using the copper nitrate, and you see here the oxygen atom of the nitrate ion is chelating the 2 metal centers and 2, or you can say 2 paramagnetic centers. Therefore, again we are getting the binuclear metal chelates after using this particular hydrogen complex. Please next, please. Next, please. Okay, thank you. Let us see when we characterize by using the several physiochemical techniques, and finally these metal chelates are characterized by using the single crystal X-ray machine. After single crystal X-ray analysis, one can get the real geometry of these metal chelates, and you see here the real geometry of each metal center which is found in this molecule. In this molecule, you see here from yellow color 2 spots are. This is for the copper center, and both copper center are paramagnetic, and you can see the geometry of this copper center, and geometry is again given in a set where the 2 large blocks show the copper center, and these 2 copper center are well connected by the oxygen atom of the nitrate ions, and therefore it becomes the example of the bridge system. And you see the distance between the two paramagnetic center in this bridge system remains 3.4 angstroms. Now, structural index value of these metal center geometry come sorted pyramidal. Geometry is not perfect because the index value is 0.26. Next, please. Next. Okay. Okay. Next, please. Back. Please go back. Please go back. Please go back. One more slide. Go back. One more slide back. Oh, you. It is a clear metal complex. Again found by centers, and this time bridged by so it becomes the example of the binuclear complex, and it's paramagnetic in nature. And in this complex, you see the the distance between two metal center means copper distance remains to be 3.297 angstrom, and value of tau he remains 0.18. So again, we can say its geometry remains distorted square pyramid in this case. Next, please. Next one. Okay, now this is the again example of the next system. Here again, hydrogen ligands are taken, and by synthesizing the newly designed hydrogen complex. Here again, it's a nitrato bridge systems, and this time the distance between two metal centers remains 3.459 angstroms, and the value of rho remains close to zero. Therefore, we can say its geometry is trigonal pyramidal, because its value is close to zero. Okay, next, please. Now we have did some theoretical calculations. Some theoretical calculation means electronic excitation involve the transitions mainly from metal ligand bonding molecular orbital to the beta spin lowest unoccupied molecular orbital with copper dx by characters, and the beta fundamentally UV visible spectrum found at about 820 nanometer. The calculated electronic excitations give rise to the same pattern of the energies in a good agreement with the experimental ones. So these are the homo-LUMO molecular orbitals of these binuclear complexes. Well, next please. Next please. Okay. Then we have studied by using the electron paramagnetic resonance spectroscopy. It's a very good technique for having the of metal chelates, as in this sense two centrines paramagnetic in nature. Therefore Therefore, we have used the electron paramagnetic resonance techniques to having the features of this compound. So you see here in these figures, uh, two EPR spectrums are given. One EPR spectrums corresponds to the liquid nitrogen temperature EPR spectrum in solution, and second EPR spectrum, which is broad one, which is of the polycrystalline room temperature EPR spectrum of binuclear complexes. And in a inset you see the some small peaks occurs around the 15 to 1600 Gauss, and the presence of such 15 to 1600 Gauss signals is known as the half field signal, because the main signal is you can see here is remains at around 3200 Gauss, but this signal which is one can say is the half field signal, it always ranges just half of the fields, that it at around 1600 Gauss. So occurrence or presence of this half field signal, this denotes that in a single molecule there is presence of two metal center is identified by occurring the such type of the half field signals. Now in the table, different ESR parameters are given in this table, like G parallel value of this becomes 2.190 for complex 1, for complex 2 it becomes 2.168, similarly G perpendicular regions. And we have also calculated the exchange in the same molecule. There are two paramagnetic centers, and therefore due to interaction of the second metal centers, so interacting features occurs, and therefore exchange parameters for this system comes out to be 3.495 for complex 1, and for complex second it comes out to be 2.520. As these values are below the 4, means there is exchange interaction in between two metal centers. Okay, next please. Well, then we have also recorded some ESR features of some polycrystalline ESR spectrum of these hydrogen metal chelates. In these metal chelates, these are the simple one. There is no strong interaction of seeing ESR parameters of given for these, and ESR parameters G parallel and G perpendicular. These are usual, not very amazing, and A parallel for these complexes comes out to be 160 Gauss for complex PC1 and electrode potential due to reduction. So as we are getting at the two humps, means two electrode potentials, two redox potential, it means this kind of the cyclic photomogram shows that in a single molecule there is a presence of two metal centers. Therefore, getting here the peaks here, and corresponding these two reduction potentials, we are getting this two oxidation peaks. So we are getting these two peaks. Let us talk about the peaks of complex 1. So first reduction potential remains 0.1 volt. Second remains at 0.3 2 volts, and 0.37 minus 0.37, and half bay potentials also calculated for these two. These half bay potential comes out to be minus 0.135 for first wave, and for second it comes out to be plus 0.205. The main feature of this redox wave is, as we are getting the two redox waves, so presence of two redox waves, this denotes that the same molecule metal center, and one can calculate it's a K con value, means K proportional value, means these copper 2 centers which remains in two oxidation states. So copper 2, first they are converted into copper 2, copper 1, and then again one electron is accepted by this mixed valent systems and it becomes copper 1, copper 1. And in the redox oxidation side, then copper 1 becomes copper 2, copper 1, and again one releasing one electron from this system, it becomes copper 2, copper 2. So, okay. Well, next page. Okay. You see here, it's a single cyclic voltamogram of such a binuclear systems. In this binuclear system, again, two redox wave and two reduction potentials are, and corresponding just above these cyclic voltamograms, some electrochemical parameters are given like EPC1, EPA1, EPA2, etc. EPC1 means it's a cathodic peak potential. EPA stands for anodic peak potential, and for peak first, and their half-way potential is also calculated for these complexes along the K con values. Next please. Okay. Then we have used for characterizing these metal chelates, which are comprises of the hydrogen ligands, are characterized by using the electronic spectroscopy. So in these after using electronic spectroscopy, one can get the two peaks. One peak remains at around 700 Gauss, and this 700 nanometer, and occurrence of this such type of peaks at around 700 nanometer. This shows it's a DD band, and this DD band have this confirms the presence of d square minus pi square orbital in the copper ions. And at higher energy side, one more intense band always occurs, and this intense band is known as ligand to metal charge transfer band. So after using these visual bands and CT band, LMCT bands, one can give those some characteristic feature of using this electronic or visual spectroscopy. Well, next page. Then catalytic features of these metal complexes were collected. The main characteristic feature I would like to tell you that we have collected their superoxide dismutase activity, catalytic activity of these superoxide is a O2 in all living systems. This superoxide is generated after so many metabolic activities, and this generated superoxide anion is very dangerous. It can cause so many disorders in the living system or in the body. So God has gifted us by giving a protein, and this protein is known as the superoxide dismutase. What is the role of this superoxide dismutase? This superoxide dismutase disproportionate this toxic toxic superoxide anion. Otherwise, it can cause cancer, it can cause diabetes, it can cause other kind of the cardiovascular disorder maybe. So we have collected the catalytic activity, means these compounds, they mimic the activities of these superoxide anion. superoxide dismutase. So we can say these are the good mimics of the superoxide dismutase. Okay. So for these complexes, we have measured the superoxide SOD value of these almost it becomes for complex first it is 35 micromole, for second it comes out to be 26 micromole, for third it is 52 micromole, and for fourth it comes out to be 58 micromoles.
Excuse me, Dr. Patel.
Okay, okay, ma'am.
Sir, we are running out of time. If you proceed fast.
I will conclude in 1 or 2 minutes because
Okay,
it's
sir.
I think it's my last slide. Okay.
Okay.
Okay. So the uh, purpose of collecting this SOD data is to compare these hydrogen complexes whether they can be used as inorganic drugs. So if they mimic, if they show the good IC50 value or good SOD activity, then they can be used as inorganic drugs or as a chemical therapy. They can be very well used. Next page. Next please. Okay. Then we have collected some antibacterial activities of these complexes also. And so see these complexes are very active for antibacterial, even some antimicrobial activities also collected and discussed. Next please. Next please. Next. Okay. Then DNA cleavage activity, DNA interactions for these complexes because they can interact with deoxyribonucleic acid. They can cleave the in centers. Even they can bind the deoxyribonucleic acid. They can also bind some serum proteins. So these properties of these metal chelates, which are comprises of the hydrogens, these such properties are collected and discussed and compared with some novel SOD mimics. Okay, next page, next please. Next please. Okay, well, we have also collected some anti-cancer feature of our compounds and they show some anti-cancer features. So these are very good. Therefore, we can say these hydrogen metal chelates which are prepared after using the copper salts, these are the very good. They show good anti-proliferative properties also. Next please. Next please. Next one. Next. Okay. Uh, so then I would like to thank to organizer again for giving me opportunity to share my work, which is already done in a river like a small city. Okay, thank you once again to all of you. If you have any query, then I can respond. I can respond.
Any queries? Any queries? Okay, thank you, sir. It was nice
Thank you,
hearing
ma'am.
you. Yes, it was nice hearing you.
Thank you.
Now, on the series, there is another eminent speaker, Professor Neelam Richaria. Professor Neelam Richaria, she completed her PhD in 1987. She has an experience of teaching experience of 41 years. She has 20 international research papers and 16 national research papers. She also published 2 books. She has also mentored 7 PhD students and 6 are currently under her research work. So, and she is a member of Indian Chemical Society, Kolkata, and National Science Sabha. She is a member. So, welcome you, ma'am, on behalf of Chemistry Department of AKS University, Satna. Hello. Hello. Richaria, ma'am. Am I audible to you? Hello. Hello.
Hello.
Hello. Good morning, ma'am. Am I audible to you?
Yes.
Yes, ma'am. It's nice to see you again.
Thank you very much.
Thank you, ma'am.
Okay.
She was my HOD at that time when I was doing MSc. Thank you, ma'am. It is very nice to see you again. Welcome, welcome on behalf of AKS University. Now, floor is yours.
Okay. Now, start.
Yes, you are audible. Please present the screen. Please
Okay.
present the screen. Samit sir, please present the screen.
Okay. Okay. Honorable Chancellor of the University, Shri BP Soni ji, Pro Chancellor Anand Soni ji, VC of the University, Dr. Banik sir, Pro VCs, Dr. R.S. Tripathi ji, and Dr. Harshvardhan ji. Dean of the Basic Sciences, Professor R.N. Tripathi ji, and all the members of the chemistry department whose hard work and given this international seminar. First of all, I would like to pray for the wellness of the people around the world and conveying my best wishes to all corona warriors, because who in this era whole world is facing the difficulties of COVID-19 pandemics. Now I will come to my topic, recent trends of chemotherapy in cancer treatments. As we know, chemistry is a central science, and the theme of chemistry is fundamentals to humanity's understanding of world, and mainly molecular transformations in chemistry results to give us foodstuffs, medicines, fuels, etc. We know that all the medicines are chemicals, and the treatment with chemicals is chemotherapy. Here we are going to talk about the treatment of cancer. What is cancer? Cancer is a disease.
Screen is not visible, ma'am. PPT is not visible. It's now visible. It's now visible.
Cancer is a disease characterized by uncontrollable, irreversible, independent, autonomous, uncoordinated, and relatively unlimited and abnormal overgrowth of tissues. Over 100 different types of cancers are known, and each one is classified by the types of cell that is initially affected to the cell. We can see cancer is the second leading cause of death worldwide, and this data is expected to increase. 6 persons die from cancer, and 40 to 50% directly or indirectly, cancer patients are of viruses may also cause cancer. In metabolic processes, free radicals, DNA copying and repair defects are also cause of cancers, and there are number of inherited genetic mutations which can be cause of cancer. Mainly when we discuss or talk about the treatment of cancer, there we can talk about anti-neoplastic drugs. Anti-neoplastic drugs are those which are medications used for cancer treatment, and these drugs are also known as anti-cancer drugs. The anti-neoplastic drugs are mainly of three types. These three types are chemotherapeutic, immunotherapeutic, and targeted therapy. In chemotherapy, cytotoxic agents which can destroy or inhibit the growth and division of malignant cells in the treatment of cancer. In immunotherapy, treatment of disease by inducing, enhancing, or suppressing an immune response. In targeted therapy, a form of molecular medicine target the cancer tissues, and by targeting the cancer tissue, it blocks the growth of cancer tissues. And these specific targeted molecules are needed for carcinogenesis and tumor growth. The immunotherapy and this targeted therapy we can see by the examples given in this slide. In immunotherapeutic work, we can see when T cells bind to tumor cells, they deactivate, and immunotherapy drug can block tumor cells from deactivating T cells. Mainly, chemotherapy is a major treatment of cancer, and in chemotherapy, actually, science is using cytotoxic because these cytotoxic drugs directly attack on cancer cells. Cytotoxic drugs of variants under alkali nitrogen mustards, ethylamine, alkyl sulfonate, nitrosoureas, trazine, methyl hydrazine, and platinum. And we all know cisplatin was the first complex used for therapy. Candidamolide. Under these, folate antagonist, methotrexate, pemetrexate, pralatrexate, purine antagonists, and pyrimidine antagonists are 5-fluorouracil and citrabine, capecitabine, gemcitabine. Third are antitubulins. These are mitotic spindle inhibitors, vinculcolides, and taxanes. Fourth, topoisomerase second inhibitors, under which etoposide, mitoxetrone, anthracyclines, etc. Topoisomerase first inhibitors, irinotecan, topocan, etc. Antibiotics mainly used are bleomycin, mitomycin C, actinomycin D, anthracycline. And miscellaneous cytotoxins are L-leucin, anagrelide, arsenic trioxide, hydroxyurea, etc. Food and Drug Association recently approved a few drugs for different types of cancers. For example, balinoate for peripheral T-cell lymphoma, ibrutinib for chronic lymphocytic leukemia, ceritinib for non-small cell lung cancer, and two more are now we come to targeted therapies. Now, targeted therapies, doctors are using enzyme inhibitors and tyrosine kinase inhibitors. In targeted drug therapies, here newer drug carrier systems are applied. In newer drug carrier systems, they enhance delivery of we can differentiate if the drug is injected directed or undirected. What's the difference? When in a tissue in undirected condition, the toxicity distributes to whole body and toxic effects enlarges. But when the drug distribution is directed, it directly goes to the tumor, and here the toxic effects are moderate. As research shows, majority of anti-cancer drugs are poor, they have poor solubility. So a new system, SCDDS, self-emulsifying drug delivery formulations, are applied for the therapy. These SCDDS formulations enhance oral absorption of poorly soluble drugs. Here some polymer drug conjugates. These polymer backbone linked with drug and targeting ligand improve pharmacokinetic profile of the drug and improve organ specific and tumor specific delivery. Next. Liposomes are also used. They are spherical vesicles. Phospholipids and cholesterol bilayer envelope for active drug particles, and in this system, drug released intracellularly. Examples are paclitaxel, teniposide, adriamycin. Antibody-dependent enzyme prodrug therapies are also applied in target therapies. In these therapies, antibody enzyme conjugate against tumor, activate tumor site by the enzyme. Example, all camptothecin. Here. Next. Nanotechnologies are also applied for cancer treatment in trigger therapy. Highly targeted therapy with high efficacy and low toxicity. Deliver anti-cancer drugs into cells without triggering P-glycoprotein pump. Here, carbon nanotubes are used, which are well-ordered, hollow nanotubes, single or multiple graphene sheets rolled into a cylinder. Single and multi-walled carbon nanotubes are used. They are consists of fluorescent marker and a monoclonal antibody at non-binding sites. They penetrate cell membrane and deliver anti-cancer drug. Superparamagnetic nanoparticles are also applied for treatment of cancer. Here, iron oxide magnetic nanoparticles are used. They functionize with recombinant single chain Fv antibody fragments, target cancer cells, injected into the tumor and then heated in an alternating magnetic field. Means paramagnetic nanoparticles, they make their alternating magnetic field that destroys the cancerous cells. Next. Nowadays, oncolytic viruses are also used in the treatment of tumor cells. Viruses that can replicate selectively in tumor cells with defined genetic lesions causing cell death include adenoviruses and RSV, designed to replicate in tumor cells that lack functional phosphorus 53. Oncolytic viruses function in these ways to damage the cancerous cell. Cancer vaccines are also maintained. Cancer vaccine contain cancer cells, parts of cells or pure antigens which give immune response against cancer cells. These cancer vaccines are also of many types: antigen vaccines, dendritic cell vaccines, DNA vaccines, telomerase vaccine, and in modern time, other treatment modalities are hormones therapies, immunomodulators, radioisotopes, and complementary system of medicine. At last, from the whole study, we have seen that the chemotherapy has taken a everyday new path for targeting cancerous cells to destroy cancer and save the body of the people who is suffering from the cancer. The period from 1982 the present has shown a remarkable growth in the understanding of many of the cellular and molecular mechanisms underlying malignant transformation of a cell. It gave us increasing knowledge about the biology of cancer. It is clear that no single therapy will serve as a panacea, and it is most likely that in the near future, agents directed against the molecular events will have to be combined with the existing standard chemotherapies for the desired outcome. In this way, we can say that if we will go in the path of advancement of chemotherapy, the danger and risk of the cancer will be less and less day by day. And in last, I would like to pay my thanks to the organizing committee and all the members of chemistry department for the organizing this international webinar, which will definitely be a medium for enhancing knowledge of the subject and hopefully leading to its vision for organizing this webinar. Thank you very much.
Thank you, ma'am. Thank you so much.
हाँ मैडम फोन उठाइए ना, कंप्लीट हो गया, फोन उठाइए।
लग गया मैं भी।
Thank you, ma'am. It was a nice presentation. Now on the series, there's next. Our speaker is Dr. Soma Saxena. She is a senior specialist in USA. She has many research papers published. She worked as a project assistant at Regional Research Laboratory, Bhopal. Did MS in molecular biology from Michigan State University, USA. worked as scientific assistant at St. Louis University, USA. She has also worked as manufacturing supervisor, oncology cell therapy project at WXI Advanced Therapies USA. Presently, she is working as a senior specialist global technical operation at Merck USA. Welcome, ma'am. Hello.
Yes, hello. Can you hear me?
Yes, yes, yes. I can hear
Okay,
you and you're visible. So you can
perfect.
present your PPT also.
Okay, perfect. Thank you.
Welcome.
Let me know if you can see my screen, please.
Yeah, yeah, sure. Not
Can
is
you
it's
see?
no, no, no. It's not visible right now
It's not yet? Okay.
yet.
Okay.
Just click on the present now.
Yep. Can you see it now?
Yeah, yeah,
Okay, perfect.
yes.
Thank you so much for the nice introduction. And thank you so much for giving me this opportunity. I just wanted to talk to, I know there are chemists and professors in chemistry area. They are all listening. So it is a privilege presenting in front of all of you. I just wanted to, talk about 3D printing revolution, which is ongoing right now, and I thought it would be a good topic to talk about. So what is 3D printing? 3D printing is the construction of a three-dimensional objects from a digital model.
Excuse me, ma'am.
Sure.
Please maximize your screen. Maximize the PPT.
Oh, you can't see it? Okay, hold on.
Yeah.
Okay.
Yes.
Can you see it now?
Yeah. Yes. Yes.
Okay, perfect. Um, okay, so 3D printing is the construction of a three-dimensional objects from a digital model. These 3D objects are usually constructed layer by layer by a machine placing filament or another substance on top of each other. This was only used for small scale parts at first, but now because technology is getting better, these 3D printing is actually being used at a large scale for other important things like organ replacements. In 3D printing, objects are made by fusing or depositing materials such as plastic, metal, ceramic, powders, liquids, or even living cells in layers to produce a 3D object. This process is also referred to as additive manufacturing, rapid prototyping, or solid free form technology. So before I go and describe what are the different uses and the different advantages and different areas which is utilizing 3D printing, I thought it would be a good idea to actually talk about what happens in 3D printing, how this 3D printing takes place. So the step one is that first you produce a 3D model using a computer-aided design software. So basically, you go to the computer and you design your model, what you want to make. Then step two is that you convert that CAD, you convert your file by from your CAD software into a different version, which goes into a STL format. It is called a standard tessellation language, and it converts your model or your design into something which a computer can understand. Then the third version is that you basically take that STL file and you copy that STL file to the computer, which controls the 3D printer. And there, a user can designate the size and the orientation of printing. And this is actually similar to the way you would set up a 2D printout to print two-sided or in landscape versus portrait orientation, which we actually get when we print a paper or something like that. Step 4 is a machine setup. So each machine has its own requirements for how to prepare for new print jobs. This includes refilling the polymers, binders, and other consumables the printer will use. It also covers adding a tray to serve as a foundation or adding the material to build temporary water-soluble supports. Step 5 is actually now the build time. So machine does its thing. It builds the process and it is automatic. So each layer is usually about 0.millimeter thick, and actually it can be thicker or thinner, whatever criteria we put into those files. And then depending on the object size, the machine, and the material used, the process could take hours or even days to complete. So if you have a small model, it will be done in few hours, but if you are trying to print a whole house or the components of the house, it will take few days. Now, step 6 is removal. So once your object is printed, you will take it out from the machine. At that time, you have to be careful because it can be very hot, and the metals are, can injure you. So it's better to wear gloves and protect yourself when you are touching those newly made objects by a 3D printer. Step 7 is post-processing. So many 3D printers will require some amount of post-processing for the printed objects. This could include brushing off any remaining powder or bathing the printed object to remove water-soluble supports. The new print may be weak during this step, since some materials require time to or so caution might be necessary to ensure that it doesn't break or fall apart. And the last step is the application. So you take your printed object and you get to use it. So this is basically a picture. So what I described in 8 steps, I'm trying to show it to you over here in just 5 steps. So first, you design your file in the computer, you turn it into a different file, then it turns into another file which can actually communicate with the printer, and then the printer goes in and it prints the actual object, and there you have a chess piece, which now you can actually take and use. So that's how a 3D printer works. So now moving on to the different fields impacted by 3D printing. So first of all, I would like to talk about chemical sciences. So under chemical sciences, 3D printing is now being used for microfluidic devices, miniaturized analytical platform, analytical methods and applications, pharmaceutical chemistry and biochemistry. And then, of course, we know that there is a very big advancement in medical sciences and mechanical sciences where 3D printing is being used currently. So moving on to the chemical sciences, one of the major use of 3D printing is in microfluidic devices. So what are microfluidic devices? So these are small chip-like devices, and we call it actually lab on a chip, basically. So these microfluidic chips are engineered devices that allow the precise routing and manipulation of small fluidic streams to miniaturize laboratory procedures. The small size makes them attractive to use in a lab environment, and user doesn't have to be a specialist, and the setup does not require a large amount of external equipment. So for a device to meet these demands, a self-contained design of operational features is beneficial. So when I talk about microfluidic devices, that means I'm talking about high throughput screening, DNA chips or microarrays, micropropulsion, and microthermal technology. So I just want to talk about one example over here, and that is DNA chips or microarrays. So what is DNA chip? It is a collection of microscopic DNA spots attached to a solid surface. It is used to measure the expression levels of large number of genes. So in synthetic biology, it is rapidly advancing in that area, and it is being used to create novel biotechnology applications, next gen therapeutics, and new methods of scientific inquiry. So we know that nowadays everybody wants to know their ancestry. We would like to, pre-screen ourselves for any diseases, and that's where these chips come in handy. And these microfluidic fabrications and operation can be expensive to require expertise and limiting access to the technology. But in the advancement in 3D printing fabrication tools, it is now possible to directly print these fluidic devices and supporting hardware. 3D printing microfluidic devices are inexpensive, easy to make, and quick to produce. And they also provide a potential one-step manufacturing approach for fabricating these devices to run DNA assembly reactions. And once these devices are generated and used, the file generated by them, it is very easy to share and download, and easy to collaborate and work with other people on these. So now moving on to the second topic under chemical sciences, the use of 3D printing in miniaturized analytical platforms or detectors. So several studies about miniaturized chemical analysis system. I'm just talking about one thing like electrophoresis, fabricated with micromachining methods were reported. These systems have some advantages, such as these are fast response, a small amount of samples, and low consumption of reagents as compared with the conventional system. So basically, if you are running an electrophoresis, you need a liter of reagent or a small, like not small, but I would say few mils of your samples at least. But if you decrease the size of your electrophoretic system, you would need only few mils of your reagent, microliters of your samples, and then you can save so much money in that area because everything has been now miniaturized. So that's where 3D printing comes in handy. So with such a small system, design of the detector units is very important to monitor analytical performance. So now if you are in some type of a spectrophotometry or doing that kind of assay where we need a detector, then 3D printing not only print that system for you, but also it can print a detector. And the commonly used detectors for analytical characterizations, including UV, ELSD, CAD, CLND, and NMRs. And I have written the details over here, but these are the detectors basically used in these platforms, which can be printed directly from 3D printing for the miniaturized system. And you can see over here the picture, basically why I brought it in here, so you can see the sizes of these. Like these are in millimeters, and very small system where rather than having some big of a machine, you can use something miniaturized, and just overall it cut a cost a lot. So now moving on to the analytical chemical methods and applications. So there is a lot going on in the area of analytical chemistry and use of 3D printing in that area. But I'm just going to talk about one example, in which is chromatography. So traditionally, in the one major limitation lies in the slurry packing methods universally employed in the manufacturing when they manufacture chromatographic columns, as the resulting lack of precise control over particle shape, size, and position has a deleterious effect on separation efficiency. We all know that column packing is so important So 3D printing has opened a new paradigm for the fabrication of precisely ordered three-dimensional packed beds. It is layer by layer production. Process enables the creation of difficult designs, including the complex network of channels, voids, and overhangs, characteristics of chromatographic stationary phases. 3D printing enables fine control over particle size, shape, precision, alignment, and configuration to create complex structures which were previously impossible to produce. 3D printing also presents the opportunity to fabricate ancillary column components such as column cartridge, including walls and flow distributors, and connecting fitting with alternate formats, for example, a spiral or serpentine. So in the right side, you can see a column which is made by 3D printing. You can print the way you want your column and then use it, and you would have more control in making and designing that column. So moving on to the pharmaceutical industry, this is something brand new, and it is now, 3D printing is now being more used in this area, but as of right now, it is really very new area where 3D printing is it's just going in that area. So in 2015, the US FDA, Food and Drug Administration, approved the first and currently only one 3D printed tablet. And this tablet is called Espritam. It is a reformulation of the anti-epileptic seizure drug. And this is the name, it's a little complicated, levetiracetam, developed by Aparicia Pharmaceutical, which is based in Cincinnati, USA. So Espritam has a layered, highly porous structure that rapidly sucks in liquid, and it collapses as soon as it touches the water to form a suspension. It is unique, which is actually difficult, and it cannot be achieved using traditional tablet or pill manufacturing methods. But by using 3D printing, this lattice work is created, which when touches a sip of water, disperses in the mouth within a second, which is actually very useful for children and elderly people who may struggle to swallow a pill. So in the right side, actually, you can see how it works. So it is connected to the computer, and basically computer is designing this lattice work of this tablet. Because of this lattice work, this tablet comes out as a porous tablet. So as soon as it touches the water, it just collapses. So it is easy to take for kids or elderly people. So this is something brand new which is going on in the pharmaceutical area. Now, the use of 3D in biochemistry, I think that's where it is being most used. We all know that biochemistry is all about models and the relationship between different molecules and atoms, and 3D printing is being used in that area to teach students to better understand the collaborations between these atoms and molecules. So most of the time, students approach biochemistry and they have this degree of trepidation, of fear, with many think that biochemistry is one of the difficult subjects. But by using 3D printer, students can find out what proteins and DNA actually look like and how they work. A thorough understanding of the function and the activity of molecules require the determination of its 3D or three-dimensional structure, which is routinely achieved using X-ray crystallography, NMR, or electron microscopy. 3D. Historically, the construction of physical 3D models were necessary to actually for investigators to validate, explore, and communicate the resulting hypotheses regarding functions of biomolecules. The development of 3D printing actually has enabled the construction of these physical models of biomolecules. 3D printing is the process of fabricating a physical 3D object from a digital file through the sequential addition of layers of a material, and then a variety of mechanisms are used in this process, and which is commonly used fused filament fabrication. And these FFF, fused filament fabrication printers, now they are available in universities and high schools, they are in library, and it is now there is a greater affordability and accessibility to these 3D printing technology, and it is now easier to convert these 3D biomolecular models into accurate 3D biomolecular models. So as you can see, this is the DNA structure, and this is the insulin 3D structure. So it is really easy to teach the students to make them understand that how these molecules work if they can actually take these molecules in hand and actually, then it is very easy for them to understand how these molecules interact with each other. So this would make biochemistry for students to easily understand. So that was those were some information for the chemical sciences. But if you move on out of the chemical sciences and go towards the medical sciences and other fields, how 3D printing is being used in that area. So 3D printing has been applied in medicine since the early 2000s, when the technology was first used to make dental implants and custom prosthetics. 3D printing is used in the medicinal field in three major ways, basically. So first is making of medical appliances that assist medical professionals when performing surgery or other delicate procedures. In addition, 3D printing can produce made-to-order jigs and fixtures for use in operating rooms. So we all know that if a surgeon is performing certain type of a surgery every single day, I'm sure that surgeon has, some type of preference that they would like to have an equipment which they uses in the surgery, but not necessarily that equipment is available in the market. So if they want to customize an equipment, they can basically model it in the computer and then print it by a 3D printer and use it in the surgery. So that's where 3D printing comes in role. And then implants to take place of bones, and finally external prosthetics such as hands or legs. So you can see over here that everything over to the right side, it's all 3D printed. And the use and the impact of 3D printing in medical sciences, it's just taking leaps and bounds. So just one more slide on the medical sciences because of its impact in that area. The bioprinting tissues and organs. So tissues or organ failure due to aging, disease, accidents, and birth defects is a critical medical problem. Current treatment for organ failure relies mostly on organ transplants from living or deceased donors. Although it's still in its infancy, 3D bioprinting offers additional important advantages beyond this traditional regenerative method, which essentially provide scaffold support alone. So such as highly precise cell placement and high digital control of speed, resolution, cell concentration, drop volume, and diameter of printed cells. So what I'm trying to say over here is that we know that if somebody needs a kidney or a heart transplant, right now the process is that we wait for a donor, right? But there is another part going on where they take a piece, where the doctor or the lab takes a piece of a donor's liver and then grow in the lab. But now then this, because of the 3D printing, now we have a third option where a 3D printer can print a liver or a kidney or a heart for a patient. And they use different materials, right? They don't use metal or anything, but they use cells to print those organs, which can basically be transplanted in the patient. And they have all the vascular system, because you do need all these blood supplies and oxygen supply to that organ. And it is really easy to print that vascular system by a 3D printer. So that's the option now we have, and this is the direction which we are going in the medical area. So now challenges in building a 3D vascularized organs. So most organs needed for transplantation are thick and complex, such as the kidney, liver, and heart. Cells in these large organ structures cannot maintain their metabolic functions without vascularization, which is normally provided by blood vessels. Therefore, functional vasculatures must be bioprinted into fabricated organs to supply the cells with oxygen, gas exchange, nutrients, growth factors, and waste product removal. So although the conventional tissue engineering, which is going on in the lab approach, is not now capable of creating these complex vascularized organs, but bioprinting shows that the 3D printing, there is a promise in that area in resolving these critical limitations. Now moving on to the impact of 3D printing on mechanical sciences. So more and more building parts are being created with 3D printing, as they are much cheaper than the normal parts. So as I said, that because the 3D printer, if you haven't seen, it's like a toaster, a small 3D printer if you want to make a small models. But now we are moving in where we are printing a whole house, the parts of houses. So these 3D printers are just getting so big in size, and they print parts of houses which can build together and build a house. So components and models for things like circuits are being made. We already know that these circuits, that's where the 3D printing is coming handy right now, where they make these circuits very easily. And in USA, entire houses have been created with giant 3D printers. These house making technologies moving around the world, and I think it would be, soon it will be cheaper to actually build a 3D printed house than a regular one. So as you can see, this is a picture which is actually made by a 3D printer. Not the whole house at once, but the pieces cake comes out from the 3D printer and you put it all together. So now this is a little bit big of a slide where I was just trying to share advantages of 3D printing. So we know that it gives you a flexible design. We know that you can go on the computer, design what you want. So that's where this flexibility comes in. So 3D printing allows for the design and print of more complex designs than the traditional manufacturing processes. More traditional processes have design restrictions, which no longer applies with the use of 3D printing. And it is a rapid prototyping. So manufacturing takes hours and days, but with 3D manufacturing, the same, the prototyping process, it's really fast. This allows for each stage to complete faster. When compared to machining prototypes, 3D printing is inexpensive and quicker at creating parts, as the part can be then finished in few hours, allowing for each design modification to be completed at a much more efficient rate. Print on demand is another advantage, as it does not need a lot of space to stock inventory, unlike traditional manufacturing processes. So what happens in traditional process, manufacturer makes something and they store it in their big warehouses, but because 3D printing doesn't take that long, you don't need those big warehouses to save the material. So when the demand comes in, that thing is printed and it is supplied. So that saves the space you need for the storage. Now, strong and lightweight parts. So the main 3D printing material used is plastic, although some metal can be used for 3D printing. However, plastic offers advantage as they are lighter than their metal equivalents. This is particularly important in industries such as automotive and aerospace, where light weighing is an issue and it can deliver greater fuel efficiency. Fast design and production, and depending upon parts design and complexity, 3D printing can print objects within hours, which is much faster than molded or machined parts. It is not only the manufacturer of the part that can offer time savings through 3D printing, but also the design process can be very quick by creating STL or CAD files ready to be printed. It also minimizes waste, because the production of parts only requires the material needed for the part itself, with little or no wastage as compared to alternative methods, which are cut from large chunks or non-recyclable materials. So not only does this process save on resources, but it also reduces the cost of the materials being used. And the best part is that this is environmentally friendly, as this technology reduces the amount of material wastage used. This process is inherently environmentally friendly. However, the environmental benefits are extended when you consider factors such as improved fuel efficiency from using light-weighted 3D printed parts. Now, everything is not all good with 3D printing, and there are also some disadvantages. The top of the disadvantage is energy efficiency. We all know that the price of electricity has been soaring over the years, and companies are trying to implement measures to reduce cost. With 3D printing, however, your business can easily down in high electricity bill. Research shows that 3D printing as a manufacturing technique uses 100 times more power than the conventional method. Because it is a printer, it needs electricity all the time. It is going to keep printing your material, but it needs electricity. So your bill is going to be really high in that area. And also the scarcity of the printing materials. So material used with 3D printing are limited. Time and research are still needed to come up with a variety of quality materials compatible with the process. But currently, plastic is the most commonly available material in 3D printing. And 3D printing technology may not be as user friendly as we like to think. Yes, you can start on the computer, you can design your model on the computer, but not necessarily it is a very user friendly technique. So because of the hype associated with this technology, many people believe that 3D printers are useful and convenient for ordinary consumer use. The shocker is that these printers do not work the same way than other printers. As I said, that these printers are more like a toaster or an oven rather than, a printer. So it is not that easy to handle these printers and print something out from there. And also these 3D printers, if somebody is really comfortable printing things and know how to print things, you can print anything over there. So one can easily create weapons. You can print a gun over there, and it is like an actual gun. So as the world gets excited about the conveniences and use of 3D printing, terrorists and criminals, they are going to be happy too, because now they don't have to buy anything. They can buy a 3D printer and print all these mass destruction weapons at home, which is not a good thing. Also layoffs. One of the significant ways 3D printing can cause disruptions include job layoffs in the manufacturing industry. The technology enables quick manufacturing and uses a single setup. So one time you make your model in the computer, you are all set. Then you don't need people in line to stand and put things together. So if we go this route, there will be many people who will be losing their jobs. At the end, I just want to thank you, Dr. D.K. Mishra, HOD, Chemistry Department, for giving me this opportunity to speak in front of all of you. I also got the chance this morning to hear some of the speakers, and it was a great privilege. So thank you so much. And also, I want to sincerely thanks to the organizing committee. I think it is a very good approach connecting everybody, especially when we are in this pandemic and working from home, and we are all at home all the times. So I think it was it is a very good platform where everybody can come together and share our experiences. So thank you so much for that. And thank you for listening to me. If you have any questions, please let me know.
Thank you, ma'am. It was nice hearing you about 3D
Thank you.
printing presentation. Yes. Hello, any questions? Any queries?
Soma, can we have some copyright issues regarding the printing by 3D means?
So I don't think so. I don't think you would have any copyright issues. I was thinking to buy a 3D printer, but those are expensive. So, but no, I don't think there would be any copyright issues. There are different computer files which are available to everybody, and you just have to buy a printer and the material which is going to go in the printer, and then those types of files, CAD files and STL files, and then you can model everything on the computer. I don't think you would have any copyright issues.
Thank you. Thank you.
Mm-hmm.
Thank you, ma'am. Any other questions? Okay.
Thank
you. So, ma'am, you
you.
can stop presenting.
Sure.
Yeah. So, last but not the least, our next presenter is Dr. Dinesh Kumar Sharma. Dr. Sharma is currently working as a senior scientific officer and assistant chemical examiner to the government of MP, India. He did his PhD in 2002 as on selective recovery of heavy metal ions from industrial effluents by synthetic ion exchange. He published a number of research articles in international journals and nationals also. So, Dr. Sharma, can you hear me? Dr.
Yes, yes, ma'am.
Okay. I welcome you all on behalf of AKS University Computer Science Department. Sir, please open your camera.
Okay, ma'am. कोई बात नहीं यार, यहीं से करना है.
Yes. Now you can present your screen. You just have to click on the present now icon.
Okay.
Please open the camera. Your camera is again switched off. Yes, you are presenting. Yes, yes. You can run the slide, please.
Okay, okay, ma'am. Just wait. वो नहीं आ रहा थी इसमें?
Yes, it is visible now.
Okay.
It is visible. Okay. So system is all yours.
Okay, ma'am. Now my topic is forensic science and its importance in crime investigation. So what is forensic science? The application of science to those criminals and civil laws that are enforced by police agencies in a criminal justice system. Basically, forensic science embraces all branches of science and applies to the purposes of law. Some exceptional are fingerprint and footprint science. Forensic science is applied science, multi-professional, and multidisciplinary science. If the investigating officer does not know to collect the correct clues or correct physical evidences, how to preserve them, how to pack them, and keep intact the integrity and the identity of the clue materials, the best of the expertise and the best of the instrumentation with the scientist would not help anymore. Function of forensic science. The most important function of forensic science is to convert suspicious into a reasonable certainty of either guilt or innocence. Forensic science provides answer to the following questions. Has a crime been committed? How and when was the crime committed? And who committed the crime? So there are 3 steps. First 2 steps, crime scene investigation, collection of physical evidences, post-scene evidence of processing causes, manner, time, etc., etc. Second is investigating stage, profiling, means, motive, and opportunity. Identification and arrest of suspect, identification by personal clues like finger and footprint, blood stains, seminal stains, hair, and many more. So forensic science help, how forensic science help in criminal justice system? There are main point are provide lead to the investigation, establish whether the scene is real or fake, means crime scene is real or fake, locate hidden clues, correct clues, and also proper sample of comparison, establishes sequence of events, verifies the prosecution versions, the defense versions, and find the correct versions, save the innocent accused by delinking him with the clues, with the victim or with the scene of crime, identifies the victim in case of putrefaction and mutilated of the body, identify the correct crime weapon. There are many principles used in forensic science. The law principles of the all science from the basis of forensic science. Means all science are involved in forensic science. In addition, it has developed the own principles. There are some principles, law of individuality. And there are unique fingerprint for individual. There are DNA for individuals. Principle of exchange. When we touch some things, we leave some traces of evidences on it. Law of progressive change. Principle of comparison. This is the main principle of forensic science. We compare all things. So we decided whether it is fake or true. Principle of analysis and law of probability. These are the main principle of forensic science. A forensic science laboratory consists the following department. There are many departments: biology, serology, chemistry, toxicology, physics, ballistics, explosive, narcotics, DNA fingerprint unit, forensic psychology, voice analysis, photography, computer and cyber cell, instrumentation unit, fingerprint bureau, government question and document examiner, and many others. In chemistry unit, we examine petroleum product like petrol, diesel and kerosene, examination of substandard construction material like bricks, cement, concrete. If a bridge is constructed newly and collapsed, then the police seize the material and send to forensic lab for its composition. How composition is in, whether cement is proper manner or not. Now next, acid throwing. Acid throwing. Have you seen some newspaper that the some criminals acid throw on woman or lady? Examination of metal and metal alloys, duplicate mobile oil and other materials. Analysis of alcohol, illicit liquor, varnish, etc. Examination of inflammable material in suspected cases of arson and dowry death. Sometime a newly married lady went to suicide by kerosene and other inflammable material, then examination is done by forensic lab. In toxicology unit, toxicology is the science of poison, so it deals with the nature, origin, property, mode of administration, physiological action, the sign and symptoms, extraction and identification of poison. The extraction of poison and its identification is the chief concern of the forensic toxicologist. There are many types of poison which we examine in a lab. There are some inorganic and organic. In inorganic, metallic, non-metallic, organic, volatile substances and non-volatile substances. Some household material is also used as a poison, phenyl and phenolphthalein balls. So metallic, in metallic poison, there are arsenic, mercury, lead, copper. Lead means sindoor, copper sulfate, aluminium, iron, antimony. Some non-metallic are cyanides, phosphorus, iodine, strong acids. In volatile substance, organic volatile substance, ethanol, methanol, etc. In non-volatile substance, alkaloid, barbiturates, glycosides, insecticide, and pesticide. So there are some pesticides which are used as poisonous substances. The most popular are organophosphorus, organochloro, and carbamate. Sometimes aluminum phosphide used as a poison, and zinc phosphide, rodenticide. Some other poisons are animal poison, snake venom, snake bite in snake bite cases, scorpion venom, insect bite, plant poison, madar, castor, nux vomica. Nux vomica is a mixture of two alkaloids, strychnine and brucine. It is very poisonous and used for killing animal or cattle. Aconite, rodenticide, चूहा मार दवा जो होता है, zinc phosphate, that is zinc phosphite. Some abortifacient uses by criminals or in other hospitals. There are ergot, quinine, and juice of madar. In physics unit, examination of tool mark, tire marks, comparison of telegraph copper wires, counterfeit coins, examination of soil, dust, dirt, and debris, examination of glass, paint, chips, and other contact traces in hit and run cases. In hit and run cases, there are transfer of paint on each other. When two vehicle collapse, there is a transfer of paint on each other. So in physics unit, we examine paint on both vehicle. It is said that the vehicle is used in hit and run cases. Restoration of erased mark numbers on stolen articles. Some theft are stolen vehicles and erases their chassis number and engine number and embrace some other number. So in physics, in restoration, we created the origin number of chassis and engine number. Examination and comparison of torn fabric and ropes, etc. In biology and serology units, identification of blood and blood stains, semen, seminal stains, saliva, sweat, tears, hair, bone, teeth, and other body fluids. In murder cases, blood and blood stains. In rape cases or gang rape cases, we examine seminal stains and semen on articles as well as on vaginal swab seized by doctors during the medical examination of the victim. Compare hairs and fibers. They are present on, they are as a physical evidence present on crime scene. Morphological examination of material like hair, wool, fibers, wood and wood fragment, pollen grains, microflora, diatoms, etc. Diatom test done in drowning cases. So diatoms are very small things and present in bones, bone marrow. Determine original and grouping of body fluid. In ballistic unit, we examine firearms, discharge bullet, cartridge cases, shotgun shells, and ammunition of all types. So voice analysis unit. What is voice analysis unit? The identification of the speaker voice by speech spectrograph is based on the principle that the dimension of the vocal cavities and coupling of the articulators are affected by heredity, sex, age, and other socio-environmental factors. It is therefore extremely unlikely that two individuals could give rise to identical voice print. After several tests, it is claimed that each voice is uniquely different to make identification through recorded voice by sound spectrograph. In vigilance cases, we use voice analysis. So there are telephone threat on tape recorded message, telephone threat on phone, telephone threat in other means. So we examine by voice analysis in voice analysis unit. This is new branch, forensic psychology. Forensic psychology means the application of the science and profession of psychology in relation to question and issues to law and legal system. Ordinarily, it based on body sign due to psychosomatic interaction to create emotions in the suspect under interrogation. The psychosomatic changes in the integration work through various methods. There are three methods: polygraph or lie detector, psychological state evaluators, and brain printing. At present, we use brain printing. Another unit is fingerprint unit. Fingerprint are unique and they are used as evidence and important because of the following feature. They are unique, they are permanent, they are universal, immutable, and classifiable. So they are frequently available in crime scene as an evidence. So there are 3-4 type: radial loop, arch, double loop. So we examine all loops and give the report. So you can see at the scene we found out the fingerprint, and this is the suspect fingerprint, and the matching of chance is the at the spot the print found indicated chance print or says chance print, or this is the suspect print. These are the matching point. So we can say the suspect is a criminal and his print present on at scene. Another unit is explosive unit. Purpose to know the precise composition of explosive and to assist the investigation agencies at the law enforcement agencies. Explosive are chemical compounds or mixture which will be application on an external stimulus such as heat, shock, friction, or ignition undergo a rapid chemical decomposition. The chemical reaction results in sudden release of large amount of energy due to liberation of gas and temperature. The pressure thus generated and thrust out equally in all directions. So there are a classification based on performance and structure. There are low explosive and high explosive, pyrotechnics and propellants, high explosive primary and secondary, then divided into military explosive and industrial explosive. We are examined in lab for explosion also. The another unit is document examination unit. In this unit, we analyze handwriting, paper, and printers of documents. Comparison of question writing and signature with known standard writing to establish genuineness or otherwise. Identify make model of age of the typewriter used in typing the typewritten document. Examination of printed matter to identify block or plates used including composed of letter types. Examination of impression of rubber stamps and metal seal with a view to identifying them. There are many examination of writing material like paper, pen, pencil and ink, examination and performance of round stamps, letter pad, pin and staples of punch holes to connect them with the sources, and too many more others, railway ticket, lottery ticket, currency notes, etc. This is a suicide note, and you can see the writing, and when we matching the writing, so there is a difference writing. We can say that it is not written by the deceased. Next unit is computer or cyber unit. It deals computer related crimes such as fraud, counterfeiting of currency, duplication of signature document, spying, revenge, theft, mischief, offense against personals. So this is cyber unit. It is in Bhopal and examine cyber related cases. Now the main is DNA unit. DNA fingerprinting is a technique involved chemically dividing the DNA into fragments which form a unique pattern and then matching that identify profile with the pattern obtained from similarly testing a suspect biological sample. So this is a DNA profiling technique. First of all, we extract the DNA from specimen. Many type of specimens such as blood, seminal stains, saliva, sweat, hair, body fluid or body muscles, tissue. Then extracted DNA is fragmentation for DNA using restriction examination, arranging the fragment on the basis of their length. Why? Agrocell gel electrophoresis, transfer of separated fragment to nylon membrane by southern blotting, then hybridization and visualization. From we get DNA, there are so many things from which we get DNA. Blood has seminal stains, hair, tissue, swab, mouth swab, saliva, fetus, urine, visceral sample. Visceral sample means intestine, stomach, lungs, liver, spleen, kidney. These are the visceral samples. Bones and teeth, fingernails, scraping, and any biological material. So basically any cell which has nucleus forensic application of DNA test, identification of rape, gang rape and murders, disputed paternity and maternity, identification of dead bodies, identification of mutilated remains, identification of missing child, exchange of baby in hospitals, all cases of biological identification. Now, scene of crime, the basic unit of all forensic science is crime scene investigation. So what is scene of crime? A scene of occurrence is the site where the incident of crime has occurred. So there are three types of scene of crime: indoor, outdoor and mobile. Indoor means in room, any crime happen in room, house or within a wall. Outdoor means field, garden, forest, etc. And mobile scene of crime means car, bus, train, river. This is the scene of crime unit team: police officer, forensic scientist, fingerprint expert, photographer, bomb and arson expert, and dog squad. These are the team. So how to investigate a crime scene? There are steps. First, protection of crime scene, prevention of crime scene, preservation of crime scene. So how we can preserve crime scene? By two methods: one, photography of crime scene and sketching of crime scene. Third is searching of evidence, then collection and preservation of physical evidence, then identification marks and label, then sealing, then forwarding by superintendent of police to lab. Collected evidence from scene of crime and biological material received after postmortem are sent to forensic lab. Examination of collected sample, examined report sent to police, police report sent to court, and court analyze the report. So this is the whole channel in criminal justice system. First, photography. Photography is an important aid in criminal investigation. One photograph is worth 1,000 words. Examine the record, physical evidences, crime scene, and it suspect localization. So how photography is important? See, this is the crushed head in national highway. So when we photograph it, so this is the clone or photograph of this material, biological material. So we can identify by this who is victim. This is blood stain footprint in a murder case. Footprint lifted in photograph and then compare with suspect, and case is detected. So this is crime scene sketch. So in burn cases, this is a case. A newly married lady burned by their in-laws and saying that he was preparing food and electrocutions, so he died. When we reach the spot, there are many things. Deceased by right-handed, but her left hand was found placed on the heater. Clothes found on the body were in disorder state. And charring on fingers. There are circular ligature marks was found present on the neck of the deceased. There was no entry and exit point of current. The main thing is presence of fibers on the around the neck, scalp hair and blouse of the deceased. You can see these are the fibers. So we search the rope, and rope was found on in a hide place. Rope and fiber present on dead body sent to the lab. Lab analyzed the fibers and rope and found that the fiber present on the dead body are the same nature. Rope seized. So this is another photograph. The wire of the heater were found plugged in the switchboard. No utensil of cooking material being found near the heater or on the spot. So it is a clear-cut murder. Lastly, in court decision, in-laws and her husband went to the jail. This is another case, death from inflammable material. Some inflammable material found on container, mug, spot. This is the crime scene of burn case. In this case, a lady murdered and yes, in kitchen, and said that it is a case of accidental burning, but on the spot we got some grains and polythene bag which were not burned. So it is another case of homicidal. This is the spot. This is polythene bag, not burned. Some grain. Bulk of grains. Now second, the most common are hanging cases. So in hanging cases, there are some outdoor cases, and this is a rope and knot. Generally we got sliding knot on neck. If there is no sliding knot, then it is maybe a case of murder. This is another case of murder. And simulating like as a hanging, suicidal hanging. In this case, we examined rope and cloth around the neck, which is a ligature material. Some human cells are found on the ligature material. When we examined with the DNA, so it is matched. There is no height. The main thing is distance from the knot tied to the hook on the ceiling to the knot tied on the neck of the deceased by 10 feet. The distances from the knot tied on the neck to the ground was 2 feet. The length of the cord in standing position was 3.6 feet. The height of deceased was 5.3. This is another murder case. This is an from tree. Suicide from tree. In this case, a human skull was found with rope. So this is another case of hanging. Now murder case. This is a child, and there are so many injuries on his body. We find some blood stains at the spot. Blood stains examined by benzidine test and found positive. The injuries on leg. This is another murder case. So there were some struggle between deceased and criminals. So we scrap nail cutting and then examined for blood and DNA test. And they were matched with suspect. This is knife on chest. Now drowning, some drowning cases are also in our societies. In drowning cases, we examine diatoms. So diatoms are minute single-celled water-living organism with silica skeleton, which show a fine structure characteristic of the species. So in a particular pond, there are particular diatoms. So when we examined the pond water and diseased bone marrow, we got same diatoms. So we can say that it was a case of drowning. This is another case of drowning. Some accidental cases or train accident, it may be a suicidal or homicidal or an accidental. So this is a photograph of train accident, a train cutting, head crush by train cutting, hit and run cases.
Hello.
Ji, madam.
Yes, sir. We are running out of time.
Okay, ma'am.
Okay. Yes, sir.
Okay, thank you.
Thank you, sir. It
Thank you,
was very
ma'am.
nice presentation and a different, totally different from all the rest of the presentations.
But time is very
Less, I think.
less, ma'am.
But some of the pictures were very distractive, but though it was interesting slides. Yes. Yeah, yeah.
But ma'am, some drug abuses are also in this unit. Next time we can present.
Yes, sir. Sure, sure. We will definitely give you that platform to present that also.
मिश्रा साहब ने टाइम कम दिया मेरे को.
No, you spoke about 45 minutes.
Yes, ma'am. Okay, okay.
Yeah. Okay, okay.
Okay.
Thank you, sir.
Thank you, ma'am.
It
Thank you
was
very
very
much.
nice listening you. Thank you.
Okay. Okay.
So on this note, we come to end of our today's presentation. Today we had many different kinds of presentations with different aspects, and the last but not the least was totally different from all rest of the all. So chemistry is necessarily an experimental science. Its conclusions are drawn from the data and its principles supported by evidence from the facts. On this note, I would like to invite Dr. Subedar Yadav, Joint Organizing Secretary of this webinar, to say vote of thanks. Yes, sir. Thank you, sir. Now it's time to say goodbye to all of you, but day doesn't last. Tomorrow we will meet again at 11 sharp 11 o'clock with our different sets of speakers. Thank you. Have a good day.